Deep in the heart of the universe, there's a mysterious and powerful force, hidden, waiting to be unlocked. It's a force that could change the world as we know it, and it's called antimatter. Let's discover what this thing is and how we could use it to turn our lives upside down. Antimatter is the science fiction fantasy come to life. You may have heard about it in Star Trek and Star Wars, but it's actually a real thing that scientists have been studying for over a century. But what is it exactly, and how is it different from regular matter? Well, let's start with the basics. You probably know that atoms are made up of tiny particles called protons, neutrons, and electrons. These particles are all made of matter, which is what we're all made of and what makes up everything around us. And antimatter is just like that, but with a twist. Instead of protons, antimatter atoms have something called antiprotons. And instead of neutrons, they have antineutrons. And instead of electrons, they have positrons. Almost got you there. Basically, antimatter is made up of particles with opposite charge, spin, and other properties of regular matter. While a proton has a positive charge and an antiproton has a negative charge, and while an electron has a negative charge, an anti-electron, also known as a positron, has a positive charge. Get it? Antimatter is kinda like an evil twin of regular matter. It's the mirror image of everything that we're all familiar with. Just like how Batman has the Joker, matter has antimatter. So, if you ever wanted to know what it's like to be in a world where everything is made of the opposite, this would be your answer. And here's the best part. When the antimatter and matter particles meet, they literally annihilate each other, releasing a tremendous amount of energy at the same time. This is why scientists believe that it could provide an almost limitless source of power. Now, you might be wondering, where is all this antimatter? Why don't we have these antiparticles flying around and throwing crazy fireworks after every touch with regular particles? Actually, scientists believe that during the Big Bang, matter and antimatter were created in equal amounts, but for some reason, matter came to dominate. So, when they started destroying each other, in the end, ordinary matter won by a hair. Why did it happen? We still have no idea. This is one of the biggest mysteries in physics. All we know is that in the end, that's how we got the universe we know today. Makes you wonder what our universe would look like if regular matter lost. But that's a topic for another day. Antimatter is considered to be one of the most fascinating things in science. It has the potential to revolutionize our understanding of the universe and, of course, may be a new source of energy. Imagine a fuel that could power a spaceship to the far reaches of the galaxy, or a power plant that could provide for an entire city. This is what we can get if we solve this puzzle. But how was antimatter even discovered? Especially considering that there was nothing left of it at the beginning of the universe. Well, scientists were able to discover it in a very clever way. First of all, we have to go back in time to the early 20th century. That's when a physicist named Paul Dirac predicted the existence of antimatter. He had a theory that for every particle of matter in the universe, there must be a corresponding antiparticle. This idea made a huge fuss at the time. But his theory was later confirmed experimentally. In the 1930s, another physicist named Carl Anderson discovered the positron, the opposite of the electron. It was the first known antimatter particle. And this discovery was a huge breakthrough in science. Scientists soon discovered more antiparticles, and it sparked a whole new field of study. Antimatter physics. We're still exploring it to this day. But how did we even discover these particles? Didn't we just say that there was no antimatter left after the Big Bang? Well, not really. There is some antimatter in space. It's just very rare, and finding it is a real treasure hunt. Scientists look for antimatter in space by searching for cosmic rays. that are made up of antimatter particles. We can also create antimatter in laboratories. Right now, scientists use super cool machines called particle accelerators for that. The most famous one is the CERN's Large Hadron Collider, which is the biggest, most famous collider in the world. These machines shoot tiny particles at super high speeds. It's kind of like a cosmic game of billiards. When these particles crash into each other, they create antimatter particles. Then, they use special containers called penning traps to store the antimatter. It's like keeping a tiny supernova in a jar. Now, thanks to antimatter, we can change our entire world. Scientists have estimated that even just a tiny bit of it, like a couple of ounces, could give you the same energy as burning millions of gallons of gasoline. So even with a tiniest amount of it, you could power an entire city for a year. It's like holding the power of a star in your hand. That's why the scientific community is working on ways to use this superpower to make our lives better. They want to use it to make electricity, like we do with coal and natural gas. In the future, it could be used as a super clean and infinite energy source. They also want to use it to power spaceships so we can travel to other planets and stars. Imagine a rocket that could take us to the farthest reaches of the galaxy, powered by the energy of antimatter. Even a small amount of it could power a spacecraft for a very long time. And that's not all. Antimatter can also be used in medicine. Scientists are trying to use it to fight cancer and make images of the inside of our bodies. It's like a super tool that can help doctors in many ways. In short, antimatter is amazing and powerful, and now we just have to figure out how to use it. And here comes the catch. Even though antimatter is super powerful, but also super tricky to make and keep around. It takes a lot of energy to make even a tiny bit of antimatter. It requires incredibly high energy inputs, making it very expensive to produce in large quantities. These are also some other problems. For example, once we've got our tiny amount of antimatter, how do we store it? We can't just put it in a jar. Antiparticles are extremely unstable, and they're also attracted to regular matter like a magnet to a fridge. So, scientists have come up with some clever ways to store it, like trapping them in a vacuum or storing them in some incredibly strong magnetic fields. And even then, it's still a delicate and expensive process. These and many other reasons explain why antimatter isn't viable for large-scale production yet. If you were trying to fill up your car's gas tank with antimatter, it would cost more than a small country's GDP. But even though creating antimatter is an enormous scientific challenge, the potential rewards are huge. That's why right now, scientists are working on finding ways to produce and store it in a more efficient and cost-effective way. And if they succeed, it could become the new ultimate energy source. Antimatter research is a fascinating and rapidly evolving field. And who knows, maybe in the future, we'll be able to power our homes and cars with antimatter. Now that would be awesome.
People are shouting and waving their hands in the auction room. The presenter can't calm everyone down because the lot on the table is the most expensive dirt in the world. Its price is about $9 billion, but it's really hard to imagine its real value. Because it's dirt from Mars. It's so expensive because it's going to take 1 decade, billions of dollars, and 3 space missions to deliver the dirt here to Earth. And we've already started the first mission. On July 30th, 2020, a single-use Atlas V rocket was launched from Earth's surface towards Mars. The cost of launching such a rocket is about $109 million. The rocket carried the Perseverance rover and Ingenuity drone. The flight took about 7 months. On February 18th, 2021, the rocket finally reached its destination. The landing module carrying the rover and drone was launched into the atmosphere of Mars. The robotic heroes traveled inside a capsule faster than the speed of sound. Underneath, the capsule was protected by a heat shield to keep its valuable cargo from burning due to high temperatures. It was time for the team at NASA's Mission Control Center to clench their fists in hope that the landing would go smoothly. The entire process was automatic. Once the cargo capsule entered the atmosphere of Mars, a parachute successfully opened. This reduced the speed of the capsule to 1,400 feet per second. As soon as its drop speed went down to subsonic, the heat shield was dropped. At this point, people saw the surface of Mars for the first time with the help of the camera and radar placed inside the capsule. The capsule was already moving at speeds comparable to that of a supercar on a racetrack. The drop speed went down to 475 feet per second at an altitude of 6 miles above the surface. That's how high planes on Earth fly. At an altitude of about 2 miles, the 8 jet engines of the landing module started. The navigation system adjusted the landing trajectory. The landing module then separated from the parachute capsule and began its independent descent at a speed of 245 feet per second. Everyone at NASA's Mission Control Center was waiting for a successful landing. 1,000 feet above the surface, the rate of the descent is 100 feet per second. At about 65 feet above the surface, the sky crane system began lowering the rover to the surface. The Perseverance released its 6 wheels like an airplane releases its landing gear. The wheels of the rover were getting closer and closer to the surface. A few more feet, and touchdown. At the same moment, the Perseverance cut the cables of the sky crane. The entire team on Earth erupted with joy. In the next second, the rover also cut the cables connecting it to the landing module. It flew off and made its own uncontrolled landing. In other words, it crashed into the surface of the red planet. The second step of the mission that's supposed to deliver the most expensive dirt in history to Earth began with collecting samples. This phase actually started long ago on Earth. The rover carries 43 titanium tubes. Each of them can hold a soil sample the size of a human pinky. While preparing these tubes in a laboratory on Earth, scientists first blew some air through the tubes. Then they bathed them in tubs with acetone and other chemicals to make sure no bacteria remained inside. Then they were placed in an oven, heated up to 300 degrees Fahrenheit for 29 hours. When Perseverance collects samples in these tubes, they can be stored there for at least 10 years. By comparison, lunar soil samples put in sealed boxes could only be stored for 10 days. Perseverance also has a lot of equipment and spectrometers to research samples. It even has a powerful laser. The rover can melt solid rocks into plasma and then analyze their composition. Scientists hope to find traces of living organisms in these soil samples. That's exactly why Perseverance landed in Jezero Crater. This crater is as wide as the Great Salt Lake and was once filled with water. You can see dry riverbeds and clay deposits there. This makes scientists believe that once there was water in that region. And since water is the basis of all life, researchers hope to find traces of its existence here. Another goal of Perseverance is to test the technology that will make it possible to produce oxygen on Mars. People would need it for breathing and as rocket fuel. To do this, the rover uses MOXIE, which stands for the Mars Oxygen In Situ Resource Utilization Experiment. This is a box the size of a hamster cage that weighs as much as a large dog. Its purpose is to pressurize Martian air so that it resembles that on Earth and then heat it up. A chemical reaction with a special metal inside the box is supposed to break one atom of oxygen from carbon dioxide. As a result, we'll have carbon monoxide and pure oxygen. If this technology proves successful, it'll be scaled 200 times. This way, we'll produce enough oxygen for astronauts to breathe and for rockets to be launched back to Earth. So the $2.7 million rover, this price includes its design cost, construction, and maintenance, will be collecting dirt and rock samples until 2023. It'll leave closed tubes with samples right on the surface of Mars, and almost a decade later, they'll be collected. People will need another rover to do that. A new mission will take several $1 billion to build. Then it'll need 7 months to reach Mars. After that, there will be another complicated landing. It'll be a simple rover with big wheels. Those wheels will help it get around Martian hills. Large solar panels will power it with electricity. This rover will gather all the samples collected by Perseverance. Then, it'll load them into a case the size of a basketball and carry it toward the rocket that will land on Mars together with it. The next step will be to deliver the findings to Earth. The rocket with the soil and rock samples will have to take off from Mars and get into its orbit. Another spacecraft will be waiting for it there. The rocket will launch the sample case, and the spacecraft will catch it. This spacecraft will then start its engines and head back to Earth. Upon arrival, the spacecraft will drop an entry vehicle. It's basically a capsule protected by heat shields with the sample case inside. When the capsule enters Earth's atmosphere, it'll get very hot because of friction with the air, but the shields will protect the samples, and the capsule will land somewhere in Utah. The whole mission to deliver the samples will last about 5 years. Only after that, the samples will be ready for research, and people will finally find out if there's been life on Mars. Was it before the birth of Earth, around 4 billion years ago? Or was it before humans became an intelligent species? Scientists hope to find the answers to these questions. That's why these samples are actually worth a lot more than $9 billion. What if Mars indeed turned out to be a potentially habitable place, and people could build a colony there? Then it'd be a few more decades of work before we could get to the Red Planet. To do this, people would have to use many dozens of rockets. First, an empty spacecraft would be sent into orbit with the help of a launch rocket. Then another rocket would deliver cargo to this spacecraft, and people would need one more rocket to refuel the spacecraft. Only then, a 7-month trip to Mars would begin. The spacecraft would have to deliver enough research equipment, building materials, and other supplies to Mars. Then we'd need to organize energy production. We could use nuclear power plants or solar panels for this. Houses for people would most likely be located underground. Mars's atmosphere doesn't have much protection from solar radiation, so people would have to hide from the sun. The next tasks would be fuel and oxygen production. Moxie could help us with this. And of course, food farming. People would grow food in airtight greenhouses right on Martian soil. But we'd still have to wear spacesuits there. To feel at home, people would have to terraform Mars. We'd have to heat the planet and create an atmosphere similar to that on Earth. The pressure on Mars right now only allows water to be in a frozen state. We'd have to make it liquid. Scientists offer many ways to do this. One of them is making a huge meteorite crash into Mars. But whatever method it is, it'd still take many dozens or even hundreds of years before we could call Mars our new home.
Have you heard about a diamond star that could put all the riches on Earth to shame? Or how about twinkling stars with surfaces made of solid iron? So let's take a look at these weird stars and try to unravel their mysteries. There's a star in the Centaurus constellation that was nicknamed Lucy in the Sky with Diamonds. Yes, it was named after a Beatles song, because it basically is a Beatles song. You see, the star was discovered to have a massive diamond at its core. Now, you may be wondering how big this diamond really is. Well, it's estimated to be about 10 billion trillion carats. That's a 1 followed by 34 zeros. To put that into perspective, the Hope Diamond, which is one of the largest diamonds on Earth, is a measly 45.5 carats in comparison. Can you imagine the size of the ring you could make with this star diamond? And it's about the same mass as our sun. But don't get too excited about the prospect of owning this diamond just yet. Even if you were Jeff Bezos, you wouldn't be able to afford it. According to Ronald Winston, CEO of Harry Winston Inc., the diamond is so big that it would likely depress the value of the market. So you'd have to settle for a much smaller diamond engagement ring. One interesting thing about the Lucy in the Sky with Diamonds star is that it's incredibly dense. In fact, it has the mass of the sun crammed into an object only a third the diameter of Earth. That's like trying to fit an elephant into a shoebox. And yet, despite its massive size, it's actually quite cool, with a core temperature of only about 12,000 degrees Fahrenheit. By comparison, the core temperature of our sun is about 27 million degrees Fahrenheit. Since the discovery of Lucy in the Sky with Diamonds, several other crystallized stars have been found, some with diamond hearts the size of Earth. It just goes to show that the universe is full of surprises, and you never know what kind of treasures you might find out there in the vast expanse of space. And this isn't the only weird star we've discovered so far. There are many strange, unexplained things in outer space. For example, let's take Vega. Vega, also known as Alpha Lyrae, is a bright star located in the constellation Lyra. It's one of the brightest stars in the night sky and is easily visible to the naked eye from most parts of the world. Now, Vega may look like a beautiful, bright star to us Northern Hemisphere folks, but little do we know, it's hiding a secret. It's actually quite squashed. You see, Vega's high spin rate causes it to bulge at the equator, kind of like a cosmic belly. It rotates once every 12.5 hours, which is pretty fast for a star, and it throws material out around its waistline. It's almost like the star is hula hooping. This material is further from the center of the star, so it experiences less gravity, causing it to cool and darken, leading to a gravity darkening effect. So Vega is basically a cosmic fitness guru's worst nightmare. Although for us stargazers, it still looks round because we're looking at it from Earth's pole end. However, if we saw it from a different angle, we'd get a very different view. One that might make us wonder if Vega has been sneaking some cosmic donuts behind our backs. But while we might joke about its equatorial waistline, there's no denying that Vega is still one of the brightest and most fascinating stars in our galaxy. But if you want something actually bright, then how about a supernova? Supernovas are giant space booms that occur when stars reach the end of their life cycle. It's like the grand finale of a fireworks show, but on a cosmic scale. They release more energy in a few seconds than our sun will produce in its entire lifetime. And this is exactly what happened to the next star of our show. This celestial object with a weird name, IPFT-14HLS. But there's a catch. It isn't your average supernova. Even though this star made a blast in 2014 and started to fade away like usual, recently it made an unexpected comeback and brightened once more. Talk about a dramatic entrance. And if that wasn't enough, this thing continued to fade and brighten at least 5 times in total, which is a bit like a yo-yo. It's like the star just couldn't make up its mind about whether it wanted to stay bright or fade away into the abyss. Also, when scientists measured the supernova's spectrum, they found that it was evolving 10 times slower than other stars. Maybe it's a supernova that just wants to enjoy its golden years. All in all, this object is a real mystery. But this is not the only star suffering from the 2-in-1 syndrome. At first glance, MY Camelopardalis appears to be a fairly common star, but after a closer look, astronomers concluded it was actually 2 stars in one. These 2 stars are orbiting each other at over 600,000 miles per hour. It's a contact binary star system, which means that the stars are so close together that they share a common envelope. In other words, they're so close to each other that they're practically smooching. These celestial Romeo and Juliet are one of the most massive known binary stars out there. Each of them individually weighs in at a whopping 32 and 38 solar masses, respectively. Astronomers also think that they might be on the brink of a stellar merger, which means that one day they might just combine into one giant superstar. Wow, who knew space could be so romantic? Next, introducing another long name, HD 140283, also known as Methuselah's star. This little guy in the constellation Libra has been around for a while. And by a while, I mean a really long time. Actually, scientists used to think it was older than the universe itself. Just imagine if it turned out to be true. But eventually, they figured out that it's actually around 14.8 billion years old, a peer of our universe. That's still pretty impressive though. This star is so old, it remembers when the Milky Way was just a baby galaxy. But despite all that, this star still has some life left in it. It's just starting to expand into a red giant, which is kind of like when you hit your 30s. Talk about aging well. But if all these things are somewhat comprehensible, then how about a star that was literally named WTF star by scientists? No, I'm not kidding. At least it used to be. Now it's called Tabby's star. It also has a more scientific name, but that one is a bit of a mouthful. But what's really bizarre about this star is its irregular dimming. For some reason, it doesn't glow like a normal star, but blinks, as if someone turned on and off a flashlight. And it's not just a little dip. We're talking up to a 22% drop in light. So it's not because it sometimes gets blocked by a planet or something. Scientists have come up with all sorts of explanations for this strange behavior, from comets to dust to even an extraterrestrial megastructure. That's right, but before your imagination runs too wild, it's important to note that the most likely explanation is just plain old dust. Perhaps the star is surrounded by some kind of dust cloud, and sometimes it prevents us from seeing it clearly. Although this explanation is still not 100% confirmed, there are still plenty of mysteries surrounding Tabby's star. One thing's for sure, it may be a bit of an oddball, but that's what makes it so fascinating. So, there you have it, folks. We're left in awe of the incredible diversity and strangeness of the cosmos. There's so much more to discover out there. So, let's keep exploring and keep being amazed by the wonders of the universe. Aristotle once said that gold was water solidified in the ground and mixed with the sun's rays. Others were sure that gold was made with the help of the philosopher's stone. When the ancient Incas first saw gold, they decided that this metal, falling from the sky, was the tears of a mythical creature. But its real origin seems much more epic. Let's go to a very distant past, to the time when there were no people or animals, to the time when dinosaurs didn't exist yet, to the era when the simplest forms of life were just being formed. Our planet resembled a huge cauldron of chemical elements. There were erupting volcanoes, earthquakes, and lightning flashes all the time. It was about 3.9 billion years ago. During this period, huge asteroids flew through our solar system. They fell on Mercury, Venus, Earth, and Mars. It's possible that asteroids also fell on the moon and left large craters on it. There was a real apocalypse on our planet. But fortunately, no one felt it because there was no life yet. Along with the destruction, the asteroids brought metals. But were there metals on Earth before that? Of course. The core of our planet is mainly made up of metals such as iron. From there, it spreads to Earth's crust, mixes with magma, comes into contact with oxygen, and combines with other elements. But how did they get into the core? Simple hydrogen and helium atoms merged and formed heavier elements inside giant stars. Then, supernovae exploded and formed big clouds of dust and gas. These clouds reached our galaxy and began to revolve around the sun. Over time, this dust and the remnants of stars formed planets. One of them was our Earth. Metals lying in the bowels of our planet are difficult to get, and we wouldn't have the technology we have now if it wasn't for that meteor shower that left metals on Earth's surface. There are two theories. The first suggests that powerful supernova explosions far from our universe formed a lot of metals from the periodic table. During the explosion, nuclear fusion started, and it created atoms of gold. Then the blast wave threw those hot pieces in different directions. They flew for a long time, cooled down in cold space, and reached our solar system. Another theory says that gold and other metals appeared because of the merger of two neutron stars. These are powerful giant stars that are many times smaller in size than the Sun, but several times heavier than it. These are objects with tremendous gravitational force and density. Their collision formed an intense gamma-ray burst of radiation that could synthesize gold. In 2017, astrophysicists observed the collision of two neutron stars for the first time. They found traces of heavy metals, including gold, using gravitational wave detectors. So this theory seems more likely. And what if we go even further? Where did stars come from? Clouds of dust and gas are scattered throughout the universe. They mix, combine into one mass, and grow like a snowball. They squeeze each other and form a gravitational force. When all the material collapses, it starts to heat up. And then, this surge of energy creates a star. Some physicists assume that stars, during their lifetime, can produce most of the elements of the periodic table. If this theory is true, then our body also consists of stars. We may be part of some gigantic supernova that exploded billions of years ago at the other end of the universe. More than 50 years have passed since the appearance of this theory, but no one has proved or disproved it. Okay, let's get back to gold. One of the largest gold deposits in the world is in southern Africa. Scientists believe that the precious metal appeared there more than 2 billion years ago after the fall of a giant meteorite. People are sure that gold is hidden in the world's oceans. Anywhere from 10 to 20 million tons of this precious metal can be underwater. But those are not large stones, but tiny particles dissolved in liquid. The extraction of such gold is too expensive. Now, let's find out how people mine gold and turn it into jewelry. At first, people find gold deposits, large plots of land or rock inside which gold is hidden. Workers begin to use picks, shovels, and machines to extract shiny pieces from the rock. Then these pieces are dissolved in a special acid that separates the gold from the solids. After that, other substances get removed from the precious metal by melting or using gaseous flora. When the gold is purified, it's checked for purity. 99.9% is the benchmark. Done! Your gold is ready to use. You can turn it into jewelry or part of an electronic device. The rarest metals on Earth also got here from stars. I'm talking about rhodium and iridium. They are several times more expensive than gold, not because of their beauty, but because of their practical value. For example, rhodium and iridium can turn harmful gases into harmless ones, and 90% of the demand for this metal falls on the automakers market. People use these metals in the manufacturing of auto catalysts. They are needed to clean harmful exhaust. When toxic substances produced during fuel combustion come into contact with these precious metals, they become their safer forms. A micro-layer of rhodium and iridium is applied to the walls of the catalyst cylinder. Gold, platinum, rhodium, and iridium are the most expensive metals. But what about the most durable ones? It's a little complicated to determine one winner because the strength of a metal depends on 4 criteria. First, there's tensile strength. This is the ability of a metal to resist tearing. For example, modeling clay has a low tensile strength because you can easily stretch it in different directions. Among metals, tungsten is perhaps the most difficult to stretch. Another criterion is compressive strength. This is the ability of a metal to resist compression. And here, chrome is one of the strongest. The third criterion for the strength of metals is yield strength. To test this, you need to make a rod or beam from any metal and then try to bend it and break it. The metal that shows the greatest resistance has a high yield strength level, and titanium is pretty good for that. And the fourth criterion is impact strength. This shows how strong the metal is when it gets dropped or hit. In this regard, iron shows a good result. Each metal has its own strong and weak sides. Chrome, for example, has a high resistance to compression, but it's weak if you try to stretch it. Therefore, people make metal alloys to combine their strengths. Okay, we've learned about the rarest and most expensive metals. And what about other elements? What's the rarest substance in the world? Meet astatine, the rarest element on the planet. There are about 0.8 ounces of this substance found in the whole world. The rate of its decay is equal to the speed of its formation. Therefore, the amount of the substance in nature doesn't change. People discussed it in the 1800s and discovered it at the end of the 19th century. But even now, after so many years, we know little about this element. In 1869, the creator of the periodic table, Dmitri Mendeleev, learned that there was a certain substance numbered 85 in the group of halogen elements. This group of nonmetals includes such substances as fluorine, chlorine, bromine, and iodine. So astatine is considered the heaviest of all known halogens and most similar to metals. It has a low melting point and conducts heat and electricity poorly. It's brittle in solid form and has a dark color. Even today, scientists don't know all its properties. It's almost impossible to find it in nature, but chemists have learned to synthesize it artificially. People don't know how to use this element because it's too radioactive. But in some laboratories, scientists conduct experiments using astatine to treat thyroid diseases.
The most expensive stuff in the universe. Yeah, grandiose. It's called antimatter. Its existence was first theorized in 1930 when the electron was discovered. Scientists thought it might mean the exact opposite should exist too, and they called this hypothetical particle positron. Later, antipodes of other elementary particles, protons and neutrons, were proven to exist as well. Morons came later. When a particle and its evil twin collide with each other, they disappear, releasing literally tons of energy, 10,000 times more than a nuclear reaction does. But there's a catch. It takes about 100 billion years to create just 1 gram of antimatter, and it can only be created using the Large Hadron Collider. That's why the cost of this substance is about $62 trillion. And we're not even close to getting that much. Throughout the entire history of space observation, only 2 objects from another star system, or maybe even another galaxy, have entered our solar system. The first one was the Oumuamua asteroid, discovered in 2017. The second was Borisov, a comet found in August 2019. The cloud of dust that surrounds it allows scientists to learn more about substances that may have come to us from another galaxy. An unusual teardrop-shaped star was found. It has almost twice the mass of the Sun and looks like a big drop of lava because of the dwarf star hanging out nearby. The little buddy attracts the energy of its big brother and distorts its surface. Black holes can do that too. There's a star about 215 million light-years away from us that got spaghettified because of the gravity of a black hole nearby. Astronomers on Earth had to use dozens of telescopes to register the event. In the end, they saw a black hole gobbling up a star, which stretched until it became a thin ray of matter. As it was eating, the hole also ejected billions of tons of star material into space. About 250 million light-years away, though, there's a miraculous survival story. In 2020, a red giant came too close to a massive black hole, 400,000 times heavier than the Sun, and got caught in its gravitational pull. Normally, this means there's no escape. Once a black hole catches something, it will never let go of its prey. In this case, the star somehow managed to get away. Most of its outer layers were slurped away by the hungry black beast, leaving behind only the molten core, a white dwarf. And using this loss of mass, it ripped itself from the black hole's tug and started circling it at an ever-increasing orbit. Scientists are sure the white dwarf is still imprisoned forever, though, because the hole continues to chip away at it even as it gets further. In the end, the star will cool down and become a planet that looks much like Jupiter. But that might only happen in about 1 trillion years. I won't be around then. And much longer than the universe has been around so far. It was proved that a planet can orbit a black hole as it would a star. The energy from the hole would feed such a planet. But to survive in such conditions and not be pumped inside the event horizon, the planet must orbit very quickly, at nearly the speed of light, and the black hole itself must spin at the same speed. I can't but imagine what kind of life it would be on such a planet. Fast? Earthquakes on the moon, or shall I say earthquakes, aren't something from science fiction. They don't occur as often as on our planet, and when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. There are Marsquakes too. For a long time, the red planet had been considered tectonically inactive, but more recent observations have shown it still has weak quakes from time to time. You probably wouldn't even be able to feel them if you stood on Mars' surface, but it means some geological processes are still going on underneath the red and dusty landscape. At a distance of 640 light-years from the Sun, scientists discovered the planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turn to it with the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on other planets. Liquid water is only one of many things that have to come together for life to appear on a planet. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that it could fill all of our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of a comparable size to the Earth. Being inside the habitable zone of a star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only inhabitable, but inhabited already. And now multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. Until recently, we thought our galaxy looked like a circular spiral. but recent research has shown it looks more like a Pringles chip. Scientists measured the distances between the Sun and other stars and created a three-dimensional map of the Milky Way based on this data. It turned out that our galaxy is slightly curved at the edges and takes an S shape. At this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those, in their turn, caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. Remember the asteroid that wiped out the dinosaurs on Earth? Who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. If it had been any closer, all life could have easily been gone. Right now, the greatest threat for us comes in the form of Betelgeuse, not the movie, but a giant star about 600 light-years away. If it explodes into a supernova, we'll see it with unaided eyes even during the day.
Imagine a universe made of antimatter. In this alternate reality, the building blocks of matter are made up of particles with opposite charges, creating a strange and wondrous world. What would it look like? Would the laws of physics be inverted? Would time run backwards? Buckle up and let's find out. First off, let's figure out what antimatter is. We know that our universe is composed of matter. Matter is made up of tiny particles called atoms. These atoms are made up of protons, neutrons, and electrons, which together form matter and make up everything around us and what we're all made of. Antimatter, on the other hand, is just like regular matter, but the opposite. Just like how superheroes have opposite powers from their villains, antimatter has opposite properties from regular matter. So, while regular matter has protons with positive charges, antimatter has antiprotons with negative charges. Instead of electrons, we have positrons, and instead of neutrinos, we have antineutrinos. It's like the mirror image of everything we're familiar with. Now, here's an interesting part. When an antimatter particle and a matter particle collide, they annihilate each other and release a huge amount of energy. This is both a benefit and a drawback. On one hand, because of this property, studying antimatter is very difficult and expensive. We have to be very careful to ensure that antiparticles don't come into contact with ordinary atoms and don't annihilate each other. On the other hand, the huge amount of energy they release could revolutionize our lives. Perhaps one day, we'll start using them in propulsion systems for space travel. Imagine how amazing that would be! Scientists suggest that at the beginning of the creation of our universe, immediately after the Big Bang, matter and antimatter were equal. But this raises the question, where did the antimatter go? If they were truly equal, our universe would have been instantly destroyed before it could have been formed. Particles and antiparticles would have annihilated each other. Unfortunately, scientists themselves are not sure. They have a theory that the laws of physics were slightly different in the early universe, leading to an imbalance between matter and antimatter. So, after the Big Bang, particles and antiparticles began to mutually annihilate each other. However, for some reason, antimatter started to disappear. In the end, matter won. This process led to the creation of our universe. In the science world, it's known as baryogenesis. However, there are also scientists who offer more grandiose ideas. For example, a team of Canadian scientists from the Perimeter Institute for Theoretical Physics, led by Neil Turok, have proposed their own theory. They suggest that two universes were born at the moment of the Big Bang, our universe and a parallel one, consisting of antimatter. This is where all the antimatter has gone. According to this theory, at the time of the Big Bang, two universes were born, and then they separated. As the distance between these universes grew, the interaction between particles and antiparticles became weaker and weaker, until matter won in our universe and antimatter in the other. But the most important question is, what would this mysterious universe made up of antimatter look like? You may imagine a universe where everything is flipped. The stars shine with an eerie blue light instead of yellow. Buildings are made of glass that reflects light in the opposite direction, and laws of physics work in the opposite way. After all, antimatter has the opposite charge of normal matter, so isn't that logical? However, it's not that simple. Initially, scientists believed that this universe could be identical to ours in everything, all due to a property that used to be known as CP symmetry. The C stands for charged symmetry and means that each elementary particle has a twin with an opposite charge. The P stands for parity symmetry, meaning the symmetry of space. That is, all three directions in our world have opposite directions in the alternate universe. This basically means something like laws of physics are the same no matter what the location is and what type of particle is being considered. So, if you were to run the laws of physics in reverse, or in a different location, or with different particles, the results should be the same. In simple words, scientists initially assumed that the universe of antimatter would be a mirror image of ours. It would be a pretty boring world where everything would be exactly the same as here. But in the 1950s, scientists were mind-blown by an unexpected discovery. Neither of these symmetries held true. For example, if you take a piece of cobalt-60, it will emit particles that spin in one direction. But if you take the opposite of cobalt-60, the particles it emits will spin in the opposite direction. But they were expected to spin in the same direction. So what's going on here? Basically, it turned out that CP symmetry didn't work for certain weak nuclear reactions. The weak nuclear force is just weird like that, I suppose. This observation puzzled scientists for years, and then they finally figured out how to solve this mystery. They added another letter to CP symmetry, T, which stands for time reversal symmetry. This means that the antimatter universe, time must flow from the future to the past. In this case, the CPT property held true. So it turns out that the antimatter universe would be a mirror image of our universe, but with time flowing in the opposite direction. So there may be a version of you in this antiverse, watching this video on your upside-down computer, already knowing the ending. Isn't that crazy? So although this universe would look similar to ours, it would also be fundamentally different. In this world, things would unravel instead of coming together. For example, broken objects would come back together to form whole objects. People would age in reverse, like Benjamin Button, and apples would fly up from Newton's head back to the tree. This, of course, is all purely hypothetical. It's very difficult for us to imagine a world where time flows backwards. We can only imagine how surreal this inverted reality would look like. But this is what the data suggests for now. There might be something we don't know yet that would make the antimatter world different. But as far as we know today, it seems this is what a mirror world made of antimatter would look like. Scientists are still studying antimatter and its properties. Understanding these properties is important for a number of reasons. First of all, it gives us a better understanding of the universe and its origins. The imbalance between matter and antimatter in our world is one of the biggest mysteries in physics. Studying antimatter can help us understand why this is the case. Second, It would give us a better understanding of particle physics and subatomic particles. This knowledge can help us unlock the secrets of the universe and make new discoveries in physics. And, of course, let's not forget about all the possible technological advancements. Antimatter has the potential to be used as a source of fuel for future space missions and other technologies. We could use this in propulsion systems to travel from planet to planet. We could also use antimatter in medicine, for example, for cancer treatment. Also in medical imaging, antimatter particles can be used to produce high-resolution images of the inside of the body, giving doctors a better view of what's going on. So, in other words, understanding the properties of antimatter is very important for science. It's a fascinating field of study that has the potential to unlock some of the biggest secrets in the universe. A universe made of antimatter would be a fascinating place. It would be very interesting to visit there and see how everything works. And the true nature of an antimatter universe remains a mystery, waiting to be explored and understood. But let's hope that we'll figure these mysteries out in the future.
While choosing the best metal to use for goods exchanging, our ancestors considered many different types. Gold seemed to be a good choice since it's resistant to corrosion and you can melt it over a flame, which makes it easy to stamp it as a coin or work with it in any other way. Gold is not that rare, but is not easy to find and extract in larger amounts with pre-industrial technology. Geologists believe most of the gold on our planet came from space with meteorite storms more than 2 billion years ago. It's one of the densest metals on our planet, and humans have mined around 180,000 tons of it by now. If you want to tell if the diamond you're holding is real or fake, breathe out on it. The genuine diamond will remain transparent, while the fake one will get foggy. There are more ways that you can shuffle a single deck of 52 cards than there are atoms on our planet. Hippos spend around 16 hours a day in lakes and rivers to protect their bodies from the hot sun. They're pretty good swimmers, but most of the time, when it seems like they're swimming, they're just walking or standing on the lake floor. The Sahara Desert used to be green because of constant changes in Earth's orbital rotations. Around 11 to 5,000 years ago, Sahara transformed after the end of the last ice age. Sandy dunes slowly became greener because of vegetation growing there. Caverns turned into lakes. Around 3.5 million square miles of the northern part of Africa was green, which attracted such animals as elephants, hippos, antelopes, and others. The definition of a desert includes low precipitation, which means very, very rare rainfall or even snowfall. Back in 1979, Sahara got covered with snow for the first time when there was a half-hour-long snowstorm. A long time ago, before trees were here, our planet was covered with giant white mushrooms. They covered most of the surface and were 3 feet wide and 24 feet tall. A bolt of lightning can reach more than 50,000 degrees Fahrenheit. That's 5 times hotter than the surface of the sun. One pineapple plant flowers only once and gives just a single pineapple, and it can take 3 years for this fruit to grow and ripen. In the 18th century, import fees for pineapple were so high that having one at home was a symbol of wealth. People would buy one and display it without eating it and enjoying its taste. We could fit the entire population of our planet in Texas without making it too crowded, since there would be 330 square feet per person. The area of Texas is almost 270,000 square miles. If you accidentally forget you have a honey jar inside and someone finds it a couple of centuries later, they will still be able to eat it because honey is one of those foods that can be preserved for a really long time. Honey is rich in sugar and contains little water, so bacteria can't grow there. It also contains hydrogen peroxide that prevents the growth of microbes. Scientists even found 3,000-year-old and still perfectly edible honey while excavating Egyptian pyramids. Some other things that can last almost forever are white rice, vinegar, soy sauce, and dried pulses. A bookworm is not just an expression for a person who's really into reading books, but an actual insect that eats microscopic mold and makes holes in poorly kept books. Stoats, also known as the short-tailed weasel, have specific tactics to catch rabbits. They jump, spin, and twist around, which is like they have some kind of dance performance to get their attention. Rabbits start enjoying the show while a stoat is getting closer. Bubble wrap was initially meant to be wallpaper. The creators wanted to invent plastic wallpaper with some kind of paper backing. Another kind of bubble wrap is performing hip-hop while covered in lots of suds. I made that up. The Eiffel Tower needs to get repainted every 7 years, which takes a lot of paint. The total amount weighs the same as 10 elephants. It also grows up to 6 inches in the summer because the iron it's made of expands due to the heat. The arches you see at the base of the Eiffel Tower are there for aesthetics. The original design included the 4 big pylons at the base to support the entire structure. People who were building it thought it didn't look that stable, and they worried visitors would be afraid to go in. They decided to add the arches around the base to make it look safer. Also, there's a secret apartment at the top of the tower Gustav Eiffel, the designer, intended for himself. Jupiter has a mass of over 3 times larger than the mass of our planet. It also has 69 moons, with a couple of them up to 37 miles in diameter, but most of them are barely 1 mile wide. Russia has a larger surface than Pluto, by more than 150,000 square miles. Russia has over 6.6 million square miles, while Pluto has only 6.4 million square miles of surface. Russia is also a heck of a lot easier to get to. If you take all the planets in our solar system and got them together, they could fit between the Earth and the Moon. The average distance is almost 240,000 miles, and the overall diameter of all planets standing next to each other is slightly above 233,000 miles. The Pacific Ocean is bigger than all land masses on our planet put together. Some sharks live inside active underwater volcanoes. Scientists discovered the so-called sharkanos, but couldn't get too many details by sending divers to investigate, since, it's too dangerous. Speaking of sharks, they've been on the Earth for around 400 million years, which is approximately 50 million years more than trees. If you're somewhere in the wilderness and hear a tiger's roar, don't worry. It doesn't have to mean the animal is very close to you, since their roar can be heard even 2 miles away. But they are very fast, though. It's relatively safe to stand on 3-inch thick ice covering a water body because this width is supposed to support 1 person. 4 inches of ice is enough to be safe for a group of people, and 36 inches can take 110 tons of weight. Avocados never ripen while on the tree, so farmers tend to use those trees as some kind of storage to keep avocados fresh until they pick them and sell them. Starfish are pretty exciting creatures with no blood or brain. However, they do have a nervous system and are sensitive to some things such as light or touch, but don't have a centralized brain as we do. They pump seawater throughout their body, which is some kind of blood replacement. Water brings essential nutrients which help its organs to function. Starfish have eyes at the tips of their arms. They're not good at seeing details as ours, but starfish can recognize different light shades, which helps them navigate their surroundings and hide from bigger predators or hunt for food. The shortest commercial flight in the world is in Scotland, between 2 isles, Westray and Papa Westray. The distance is only 1.7 miles, and the flight takes only 90 seconds. Getting through security takes longer. One of the world's most famous painters of all time, Vincent van Gogh, sold only 1 painting during his lifetime. Now his paintings decorate literally everything, from shower curtains and coffee mugs to the most prestigious museums. The biggest snowflake ever was a 15-inch giant, the size of a frisbee. A platypus can give you one of the most unpleasant stings a human might experience, because these animals have poison glands in their hind legs. They use a hollow spur on their heels to release the venom. Cats have more toes on their front paws. Like plenty of 4-legged mammals, cats have 5 toes on the front, but they only have 4 toes on their back paws. Scientists believe that might help them be faster. If you could get into your car and drive up to the sky at the average speed of 60 miles an hour, it would take you only 1 hour to leave the Earth's atmosphere and get to outer space. You'd have to be prepared well if you decide to keep going up to the moon, since it's 250,000 miles away. That would take you as long as driving around our planet 10 times, maybe less than 6 months. Bring a big lunch with you. Guess what? Scientists have come up with a cool idea about some cosmic creatures saying hello to us from the center of the Milky Way. Astronomers are all excited about finding extraterrestrial life, so they're focusing their search right at the heart of our galaxy. Imagine stars in outer space, like super cool DJs, spinning their own unique beats. But instead of music, they send out these special signals called radio pulses. It's their way of saying, "Hey, what's up, universe?" These radio pulses are basically little bursts of energy that travel through space. They're not just random noise, though. They have a specific pattern that makes them stand out from all the other sounds out there. It's like a secret code or a special rhythm that only these stars know how to create. Scientists are super curious about these radio pulses because they think that maybe, just maybe, intelligent beings from other planets could be using them too. It's like a galactic language that they could use to talk to each other. So, these clever scientists created special tools and software to listen in on these signals. It's kind of like tuning into your favorite radio station, but instead of music or talk shows, they're trying to catch these cosmic beats. They're hoping to find those unique patterns that could be a sign of other space beings trying to communicate with us. They used a super cool telescope called the Green Bank Telescope in West Virginia to collect data and search for these signals. But here's the twist. They didn't find anything this time. No worries though, because their fancy software is lightning fast and it'll help them search even better next time. But why did they pick the center of the Milky Way for this ET life hunt? Well, that's because the galaxy's hearts are packed with stars. In other words, there should be many more planets in there, which means more potential places for life. Plus, if there are super smart life forms at the core of our galaxy, they could easily send signals to lots of planets all at once. Sneaky, huh? This whole thing is super exciting because it's the first time scientists have gone all out to search for these types of signals. They think that using specific frequency ranges and repeating patterns is a really clever way for ET beings to make themselves known. I mean, that combo is so unlikely to happen naturally, right? The best part is that they have this algorithm thingy that can go through a crazy amount of telescope data in just 30 minutes. So, even though they didn't find anything yet, they're confident that this speedy method will help them find evidence of advanced life in the future. How awesome would that be? As you know, humanity has been searching for buddies from outer space for a very long time. This research is just one of many attempts to find them. There's a whole institute dedicated to this mission in the US, SETI, or Search for Extraterrestrial Intelligence. So, naturally, the question arises, why haven't we found anyone yet? It's like we've been scanning the sky forever, hoping to catch a glimpse of advanced civilizations out there. But we get absolutely nothing. All this brings us to the famous Fermi paradox. It's like a big mystery that fuels the hunt for extraterrestrial intelligence. We think that if intelligent life exists, we'd have evidence of it by now. Maybe they're actually beaming out radio signals for us to pick up. Or maybe they're just broadcasting in general and we happen to stumble upon it. They could even have left cool artifacts in our solar system to keep an eye on us or just hang out. Heck, maybe they're building wild mega engineering projects, like gigantic solar panels around their stars. Or they could be getting all fancy and contaminating their stars with heavy metals just to announce their presence. So the search continues. We're not giving up just yet. And hey, maybe instead of just focusing on smart space beings, we should be on the lookout for any kind of life at all. Yeah, I know that a tiny microbe might not be as thrilling as chatting with friendly otherworldly creatures. But think about it. There could be lots of simple life forms out there. We're talking about simple organisms swimming in oceans, mossy creatures holding onto rocks, or the first signs of critters exploring their habitats. They might not be super brainy, but they leave their mark. Plus, they could be way more common and easier to find in our galaxy. Now take Earth, for example. There's a theory that our atmosphere used to have a lot of oxygen floating around. But oxygen is a bit wild and doesn't stick around for too long. It either escapes into space or bonds with other elements, changing into different things like carbon dioxide. Then, around 2 billion years ago, single-celled organisms decided to gobble up carbon dioxide and burp out oxygen, completely changing Earth's atmosphere. Life here transformed the very nature of our planet. And guess what? We can actually detect changes like that on other planets. Here's how. When we look at faraway planets called exoplanets, sometimes they cross in front of their parent stars. As the star's light passes through the planet's atmosphere, it gets all mixed up with different elements and molecules in the air. And you know what happens? The light changes its flavor and color in a special way. So imagine you had a glass of lemonade and you added some fruit juice to it. The lemonade would taste different, right? Well, it's kind of like that with exoplanet atmospheres. When we see the star's light that has traveled through the planet's atmosphere, it gives us clues about what's in the air and how it's different from just the star's light alone. So by studying these changes in light, we can figure out what kinds of elements and molecules are present in the atmosphere of a faraway planet. It's like a cosmic chemistry experiment, and it helps us learn more about whether there might be life out there. So right now, we can only study the atmospheres of big planets that orbit really close to their stars. But don't worry, NASA's Transiting Exoplanet Survey satellite is on the case. It's finding lots of interesting planets that we can check out more closely with the super-powered James Webb Space Telescope. This amazing telescope can even sniff out if there's too much carbon dioxide on other worlds. And okay, let's be real, our first contact probably won't be as flashy as in the movies. No exchanging secret codes or figuring out ET customs. We won't be chatting about funky bodies or habits either. Instead, the first hint of life out there will most likely come as a little wiggly line on a graph. It shows us that living creatures have really shaken things up on their home planet. Even simple life forms can have a big impact on their environment and leave behind a noticeable trace. Sure, it might not be as wild as battling space robots or epic adventures, but imagine this. Finding any kind of life beyond Earth would be huge. We'd be calling home, sending messages like, "Guess what? We're not alone in the universe." It would be an historic moment we're celebrating. And by the way, we've already begun to find organic molecules in space. It's not a full-fledged life as we imagine it, but it's still pretty neat. For example, we've already started to find organic compounds on Mars. And there's a teeny tiny chance that Mars once flourished with plants, and maybe even animals. This is just a possibility, but if it turns out to be true, it would show that the presence of living organisms in the universe is not as rare as it seems. The search for life in the universe is like a great detective game. We thought that finding it would be easier because they could do cool stuff like blasting radio signals or transforming their whole solar system. But looks like, in reality, things are much more complicated. Nevertheless, we shouldn't give up. Let's keep searching and hoping that this new study about radio signals brings some results.
Not unlike a giant cosmic blinker, a supermassive black hole 570 million light-years away flares every 114 days. Recently, astronomers have noticed powerful eruptions of light coming from the hole. The monstrosity is about 20 times the mass of the one at the center of our home Milky Way galaxy. So far, the only explanation scientists have is the black hole is ripping chunks of matter out of an orbiting star. It happens every time it gets too close. This discovery is rather exotic because no one has ever seen a black hole do something like that before. Usually, if a star comes close to a black hole, the space monster shreds it into thin strands, like spaghetti. After that, the black hole swallows most of the star's matter. The remains arc away in long, bright streamers. But not in this case. Every time the star approaches the black hole, it loses about 3 times the mass of Jupiter, and that's the largest planet in our solar system. This also results in a tremendous flare that astronomers can see on Earth. The flares are so regular and consistent that the researchers managed to predict several of them. They happened on September 6th and December 26th, 2020. A nebula is a cloud of dust and gas in outer space. You can see it in the night sky, either as a bright patch or, vice versa, a dark spot against some glowing matter. The Red Rectangle Nebula in the constellation Monoceros, or the Unicorn, is unlike others. Our universe has very few straight lines. And here you are, looking at a giant rectangle, which is a huge gaseous nebula, no less. And then, there's also the color, a bizarre shade of orange-red. Astronomers suppose the glow might be coming from some unusual activity inside the dust clusters. This activity is likely to be going on at the molecular level. The universe is around 13.8 billion years old, but HD 140283, a star informally called Methuselah, is apparently more than 14 billion years old. Even more paradoxical, the star has some chemical elements that are more typical for a second-generation star. Those are the ones formed from dust and gas left after the explosion of the first generation of stars. And still, the main problem is, how can a star be older than the universe itself? So far, the most likely explanation is an error in observations. It could make astronomers believe the star is older than it is. The star called Vega is relatively close to us, a mere 25 light-years away from the Sun. It's not the most usual star out there. It's brighter than it's supposed to be, and it's not round, but rather egg-shaped. Astronomers claim that's because the star rotates so fast, its shape changes. See for yourself. It takes the Sun 27 days to make a rotation, and Vega needs only 12.5 hours to turn on its axis. This speed also influences the temperatures on the star's surface. Its poles are several thousand degrees hotter than the equator. There's a supermassive black hole 250 million light-years away from Earth. It produces the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. The Fermi bubbles confuse astronomers to no end. It's not every day that our home galaxy blows bubbles that are hotter than 7 million degrees Fahrenheit. Coming from the center of the Milky Way galaxy, the spheres are made up of nothing but powerful gamma rays. It would be a bit less strange should one bubble stay inside the other, with both of them at the center of the galaxy's core. But the two giant spheres hover independently above and below the black hole at the center of the Milky Way. Even more bizarre, they touch and form an hourglass shape. It makes the entire structure look like the number 8. The bubbles themselves are well defined and slightly sharp-edged. They're also breathtakingly enormous, spanning a total length of 50,000 light-years. Scientists have yet to crack several mysteries connected with the Fermi bubbles, like what can produce such extreme energy? It's as powerful as 100,000 exploding supernovae. Or, what's with the off-center nature of the bubbles? Something must be going on there, even though it seems that the bubbles surround nothingness. K2-141b, a planet outside of our solar system, seems to be not that different from Earth. If you visited it, you'd see liquid oceans evaporating into the atmosphere. Just like on our home planet, the vapor then condenses and gets back to the surface as rain. But instead of water, all this happens with rock. The surface of the unusual exoplanet is covered with lava seas. In most places, they're tens of miles deep. And since the temperatures on the planet reach 5,000 degrees Fahrenheit during the day, the magma in the oceans vaporizes into the atmosphere. After that, supersonic winds, moving at a speed of 1 mile per second, carry the rock vapor to the planet's night side. There, the vaporized magma cools down, becomes liquid again, and falls to the surface as rocky rain. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. the planet completes one full orbit around the red dwarf Gliese 436 in 2 days, 15 hours, which means it travels remarkably close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet has huge volumes of water ice, known as Ice X. It remains solid despite blistering temperatures. Neutrinos are teeny, almost massless particles that can move at nearly the speed of light. They can easily pass even through metals and travel miles and miles without anything to stop them. You can be sure that some neutrinos are passing through your body right now while you're watching this video. These elusive subatomic particles get born in supernova explosions and in nuclear reactions inside stars. About 4,000 light-years away from Earth, in the constellation of Serpens, there's a bizarre planet. Astronomers think it could once be the core of a massive star, long gone now. 5 times the size of Earth, it seems to be one enormous diamond. The planet is denser than any other discovered so far and is made up of mostly carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Most stars move around the center of their galaxies following fixed orbits, but not HE 0437-5439. This 30-million-year-old star that appeared not far from the center of the Milky Way decided to set off on a journey. Astronomers think the star might have come across the supermassive black hole Sagittarius A star, and the space monster might have pushed the star out of the galaxy. It's now traveling through the Milky Way's outer halo, moving right into interstellar space at a speed of 1,600,000 miles per hour. Stellar halos surround galaxies and are home to stars and star clusters. This discovery turned out to be extremely confusing. Such short-lived massive stars, because tens or even hundreds of millions of years is a very young age for a star, aren't usually found in the halo. There, you can only encounter the oldest stars in our galaxy, those that are at least 10 billion years old. When disastrous magnetic field collisions occur at the sun's equator, they cause ginormous tsunamis of plasma. These tsunamis move across the star's surface at a speed of 1,000 feet per second. Such a tsunami can last for weeks at a time. They happen almost every decade. More than 7,000 light-years away from Earth, there is the Eagle Nebula. It's a young cluster of stars, just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, towering tendrils of interstellar gas and dust. They're also a part of the nebula's active star-forming region. Newborn stars are hidden in these wispy columns. Unlike their supermassive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. But even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims tons of micro black holes could have appeared right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that several mini black holes pass through our planet every day, totally unnoticed. Scientists think white holes might exist, even though none has been found yet. When some space object comes across a white hole, it can't enter it from the outside, but light and matter can escape from within the hole.
It's kind of weird, but mining finds are often some of the most exciting discoveries. Ready for a treasure hunt? Or maybe we can just take a look at what other people found, without leaving our comfort zone, you know. Tanzanite is a stone that's more valuable and expensive than diamonds. This gem was first discovered in 1967 in, the name probably gives it away, Tanzania. Tanzanite became popular after Tiffany & Company began to use it in their jewelry. The stone cost $200 to $350 per carat. This number isn't that high compared to other gems on my list, But experts say that the stone's price will rocket up in the next 20 to 25 years. Its deep blue-violet hue differs the gem from others. Plus, it can only be mined in one place on Earth. The next gemstone is red beryl. Although they're not as rare as some others, like black opal, it's hard to find gem-quality ones. And you can only come across red beryl on a mountain in Utah. Yet, with its few different shades of a darker red, this gemstone is one of the rarest in the whole beryl family. Prices for this red beauty can reach up to $10,000 per carat, but good luck finding it on sale. With their mesmerizing green hues, emeralds are quite popular. Most emeralds have minor imperfections, like me. On rare occasions, a natural emerald without any flaws appears on the market. It can be sold for jaw-dropping money. Oh, that would hurt. For instance, when the historic Rockefeller Emerald was auctioned off, the 18-karat gemstone was purchased for $5.5 million, which is $305,000 per carat. This way, it broke all records, being the highest price per carat emerald ever sold. Now, opal is a valuable multicolored stone, found mostly in Australia. The most common types are white, gray, and green opals. But here, I want to focus on the rarest one, black opal. Black opal has many colors in it, like a rainbow. And each time you look at it, you may see some other colors that you haven't noticed before. It's really hard to mine this one. There's no guarantee at all that you'll find it. This virgin rainbow opal is valued at $1 million and has become the world's most expensive opal. It was discovered in 2003 by John Dunstan. What's even cooler is that it was found inside an ancient cuttlefish skeleton. Who would think of looking there? This is a ring with the sunrise ruby. Its name comes from a poem with the same title written in the 13th century. What makes this stone famous, it's not its name though. It was sold in 2015 for $30 million, which made it the most expensive ruby ever. The buyer's identity was kept secret. Comment below if it's you. It isn't just gemstones that cost a fortune. Here is one of the most expensive metals in the world, rhodium. It's not as well known and popular as, let's say, platinum, but it is gradually becoming one of the hottest things on the market. 80% of the demand for rhodium comes from the global automotive industry, so it's wanted, but it's super rare. Annual rhodium production is around 30 tons. For comparison, gold miners dig up between 2,500 and 3,000 tons of this precious metal every year. Now, you can see why rhodium is so pricey. The term gold nugget makes me smile and feel hungry at the same time because it's too close to chicken nuggets. Really? Yeah. Anyway, the world's largest gold nugget is now older than a century. Two miners found this huge chunk of precious metal in the gold fields of Australia in 1869. It weighed 214 pounds and was 24 inches long. The miners named it "Welcome, Stranger." These two people instantly became rich. In those days, you could turn into a millionaire overnight. Nowadays, we have Lotto. Very unlikely, but possible. One of the grandchildren of the miners said that when people heard her name, they always asked her where the gold was or if she was rich. She answered that she wasn't. In fact, she didn't have any jewelry made from the welcome stranger. Well, that's a shame. Imagine you're 12 and find a diamond worth $15,000 while you're walking in a park. This actually happened to Michael Detlef. He probably used all his luck in life that day. Of course, in a normal park, you can see trees, leaves, rocks, and so on. But in the Crater of Diamonds State Park, you can find a real diamond. This park is very special because it's where 8 of the largest diamond deposits in the world are located. And anyone, literally anyone, can just go there and search for diamonds. And it gets even better. The policy is finders keepers. So yeah, just go find yourself a diamond there. You might even turn out luckier than Michael Detlef, and he found the 5.16 carat diamond after less than a minute search. Have you ever seen the largest orange diamond ever sold at auction? Well, it was bought for $35.5 million in 2013. This is about $2.4 million per carat, which is the highest price per carat paid for a colored diamond at auction. Now, miners have recently discovered the largest pink diamond found in more than 300 years. The diamond has the nickname Lulo Rose, which comes from the Lulo mine in northeastern Angola. The pink diamond weighs 170 carats. Right now, the largest pink diamond in the world is the 182-carat Darya Ainur from the Iranian collection of national jewels, but the newly discovered Lulo Rose is almost as large. Pink diamonds are relatively rare, too. Science can't fully explain what gives the gem that rosy hue. Hey, maybe they're shy or embarrass easily. But the fact is that they're worth a lot of money. In 1999, miners in South Africa uncovered a rough 132-carat pink diamond, later called the Pink Star. In 2013, the Pink Star was sold for approximately $83 million at auction. This way, it became the most expensive gemstone ever sold. In 2000, miners found a gigantic jade stone in Canada, 18 tons. They wanted to keep the stone, but then they got a generous offer. The buyers wanted to turn the huge piece of jade into a Buddha statue. Eventually, the stone was carved into a statue weighing 4 tons. Now, you might be sitting on a fortune hidden under your house or in the backyard. Every now and then, people discover strange and valuable things on their property. This is what happened to a lucky gem trader in Sri Lanka. He had problems with the water supply, so he decided to have a well drilled in his backyard. Workers found a 2.5 million carat sapphire cluster there. It weighed more than 1,000 pounds and was worth around $100 million on the market. Well, that should fix his water supply. We talk about rare black opals, and I can't help but mention opal pineapple. It's one of the rarest and most fascinating types of opal. It's not a fossilized fruit or something like that, only the shape of this cluster of crystals resembles that of a pineapple. These opal pineapples are only found on the White Cliffs in Australia. Now, if there's a gold nugget, there should be silver nuggets too, right? And they do exist. In fact, the largest silver nugget ever mined was found in the United States. It weighed 1,853 pounds. It was too large to be carried in one piece, so it was cut into 3 pieces and moved from the Smuggler Mine near Aspen, Colorado in 1894. Now look at this sparkling purple gemstone. The Empress of Uruguay is the perfect amethyst geode in the world. That's a hollow rock with thousands of perfect crystals that formed inside. This geode is 130 million years old. It's 11 feet high and weighs 2.5 tons. So imagine extracting something that big from the soil. It took miners 3 months to take it out from the solid basalt which surrounded it. So, what would you do if you found something as precious as these treasures?
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises, too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view, and the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a 3rd temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute zero. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history. The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are, and they can now determine the temperature of a certain object from its light. On average, Space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up. Like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes. At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form. since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter, though. They would have just exploded as supernovas on their end, and they would leave heavy metals across the space around them. Those are the particles rocky planets formed from. Radiation spread around the whole universe back then. It has changed over time. Today, it's almost an absolute zero. 400,000 years after the Big Bang, when hydrogen atoms were forming, CMB was almost as hot as the surface of our sun. And about 15 million years after the Big Bang, its temperature was close to room temperature, which is around 80 degrees Fahrenheit. These things were happening across the universe, so there were many planets that could potentially hold life. If we were one of those ancient worlds, we wouldn't need a star to keep us warm. CMB would be enough to do it. So, it's possible that life in space is way older than we think it is. There could have been ancient worlds with liquid water on their surface. What if there were some primitive forms of organisms, like on our home planet a long time ago? Or even more developed ones? Perhaps we'll find out one day.
Now, as a child, weren't you taught not to play with your food? Well, apparently these astronauts weren't. Floating Jell-O cubes across the cabin while in zero-G is a lot of fun. But it is also a sign of a potential problem called space euphoria. No one ever considered that extreme happiness in space could become a severe problem, but it can become a serious problem, and that's no kidding. For many years, space euphoria went undetected, although it was right there, front and center for all to see. When Apollo 14 astronaut Alan Shepard smuggled golf balls onto the moon and tried to create a tiny moon for the moon by attempting to hit a golf ball into orbit around the moon, everyone thought it was funny. Apollo 16 astronaut Charles Duke thought it would be funny if he tried to compete with the 1972 Olympic athletes back on Earth. He attempted to outjump the Olympic athletes to benefit from the 1/6 gravity on the moon. Duke jumped so high that he rotated onto his back and fell crashing onto the life support system in his backpack. It could have been a fatal fall if the bag had cracked. Duke's commander, John Young, said, "That's not funny," and it sure wasn't. Yet, when Apollo 17 astronauts began dancing and singing children's nursery songs while collecting rock samples, everyone still thought it was cute. Space euphoria again went unnoticed. As early as 1965, when Ed White became the first American to walk in space on a tethered spacewalk, his space euphoria became evident. He stayed out much longer than was necessary to test his mobility with the very first jetpack, or MMU as it was called, officially the Manned Maneuvering Unit. In his own words, "I'm not coming back. This is fun." Finally, when ordered to return to his Gemini spacecraft, Ed White said it was the saddest day of my life. Obviously, something sinister is at work with space euphoria. Weightlessness, combined with the view of Earth passing below, creates an exhilaration that overcomes all sense of duty. It is the great danger of space euphoria. Now, in hindsight, the effects of space euphoria could be seen when Apollo 17 astronauts drove the lunar rover on the moon. They exceeded the recommended speed limit and could be heard whooping and yelling as the rover rocked onto two wheels, even becoming airborne at times. Canadian astronaut Chris Hadfield was busy at work during his tethered EVA, extravehicular activity, when he paused to look over his shoulder. The glory of space smacked him in the face. He was so emotionally overwhelmed at the magnificent beauty of the Milky Way galaxy that tears began to fill up Hadfield's eyes. Now in space, tears do not flow down your cheeks. They pool up in your eyes. Hadfield had become blinded by tears of joy. But Hadfield, against protocol, refused to tell his supervisors on Earth. Only after he was no longer able to work did Hadfield speak a famous quote, "Houston, I have a problem." It was a direct result of space euphoria. Astronaut Hadfield managed to get back into the space shuttle, but his EVA was not fulfilled. Space euphoria had interfered. There is another aspect of space euphoria that deserves serious attention. It is something called the overview effect. Weightlessness in space affects everything from the physical and psychological health of the astronauts to the physics of using all the mechanical equipment of the spacecraft. However, weightlessness in space is not due to a lack of gravity. Astronauts orbit Earth less than 300 miles up, called LEO, low Earth orbit. There's plenty of gravity in low Earth orbit. The Earth's gravity keeps the Moon in orbit, and the Moon is about 250,000 miles away. In fact, a 150-pound astronaut would weigh 142 pounds in LEO. Weightlessness in space is due to free fall, not lack of gravity. What goes up must come down. The rocket blasts off, and about 8 minutes later, the engines shut off. The spacecraft begins to fall back to Earth. Fortunately, by this time, the rocket has achieved orbital velocity, which is about 17,500 miles per hour, so that it falls towards Earth but never hits the Earth. It keeps falling and falling around and around, precisely in the same curved path as the surface of the Earth. It's in orbit. It is free fall. Even though everyone calls it zero-G, it's not. If you were to place a bathroom scale under your feet when in free fall, it would show 0. You would weigh nothing. That's because the bathroom scale is falling too. The exciting thing is that astronauts retain all their muscle power. Their mass stays the same. Therefore, they can lift heavy equipment in space that would weigh hundreds or even thousands of pounds on Earth. Astronauts become superhumans in space, and that creates another unusual situation. There are lots of unusual situations in space. On the very first trip to the Moon, the Apollo 8 astronauts were not even scheduled to look back and photograph the Earth. Apollo 8 astronauts took only a limited number of pictures of Earth. That's unusual and kind of weird. But Earthrise from the Moon became perhaps the most influential environmentalist picture of the 20th century, and it wasn't even planned. But this is the key to understanding the overview effect – surprise at the unexpected. Even today, almost all globes of Earth are not of Earth. Globes in schools and libraries show each country, usually in different colors. Each country, sure enough, contains a star, but it is to mark the capital city of that country. It is not how the Earth looks from space. These globes are not globes of the planet Earth. In fact, it isn't easy to even find a globe of the planet Earth. Read the labels on these classroom globes. The geopolitical world. These are globes of a place called the world. There is no planet called the world. The world does not live in space. It lives on someone's desk or shelf. The definition of space is geological in origin. Space is defined as existing up to, but not including, the atmosphere of Earth. Earth isn't even an astronomical object. It explains why the very first mission to the Moon, the Apollo 8 mission, had not scheduled any pictures of Earth. Selfies weren't invented then. It also explains why the psychological impact of seeing Earthrise from the Moon was so profound. It was a unique and totally new perception for which any and all humans were utterly unprepared. Seeing Earth in space was a complete surprise. Imagine yourself floating in space outside the spacecraft. You are surrounded by the Milky Way galaxy blazing with millions of stars. The planet Earth is a blue marble passing beneath your feet. Pretty heady stuff. How would you react? Would it change you? Apollo 9 astronaut Rusty Schweickart felt strongly that he was what he called the sensing element for humanity. What does he mean? It's the overview effect kicking in. Schweickart felt that he was connected to all the people on Earth. He compared it to being born into a new existence. And astronaut Schweickart is not the only one who felt the overview effect. Apollo 14 astronaut Edgar Mitchell had this to say about being in space. It was rather an extension of the same universal process that evolved our molecules, and what I felt was an extraordinary personal connectedness with it. I experienced what has been described as an ecstasy of unity. I not only saw the connectedness, I felt it and experienced it sentientally. I was overwhelmed with the sensation of physically and mentally extending out into the cosmos. Some years after returning from space, astronaut Mitchell started an institute to study the brainwaves of people who had been in space. And yes, they are different. According to Mitchell's institute's research, the euphoric sensation of oneness with the universe creates brainwaves similar to meditating monks. Mitchell's studies were so significant that NASA launched a special Space Shuttle mission in 1998 just to study the effects of space on the brain. The Neurolab mission studied brain cells of laboratory animals, and the astronaut crew too. as brain cells try to adapt to the freefall environment in low Earth orbit. Well, we can't all be astronauts, but now we can all access virtual reality experiences of what the astronauts saw in space. The internet has opened up our Earth-bound point of view to share the unity and oneness of the overview effect, and give us a small taste of the space euphoria astronauts get in space.
Have you ever wondered why Earth doesn't have rings? Gas giants, Jupiter, Saturn, Uranus, and Neptune, have them. But the rocky planets, Mercury, Venus, Earth, and Mars, don't. Two theories describe how ring systems potentially developed. The first one says that rings may have formed from leftovers that date from the time a certain planet was forming. Or, as the second one says, they could be the remains of a moon that was either destroyed in a collision or broken apart by the gravitational pull of its parent planet. Scientists still don't know why the gas giants have rings, but they think it could be because they formed in the outer solar system. Rocky planets formed in the inner area of our solar system, which is why they were more protected from potential impacts and collisions that might have formed rings around them. Or the reason is that the bigger planets have a larger volume, which allows a ring system to remain stable. Some scientists think our planet did have a ring system a long time ago. In its early stage, a Mars-sized object hit the Earth, and this probably resulted in a dense ring of debris. But its ring system pretty soon coalesced, and that's the way our moon was formed. More than 10 years ago, in 2011, astronomers found a huge water vapor cloud about 12 billion light-years away from our planet. This cloud is the oldest source of water that we know of. It dates back to when the universe was only 1.6 billion years old, and now it's 13.8 billion years old. This unusual cloud is also the biggest source of water that we know of. It holds 140 trillion times the amount of water that the Earth contains in all its oceans. Enormous. The cool thing is, this vapor cloud is kind of feeding a black hole. It may contain enough gases, such as carbon monoxide, to help its black hole grow even 6 times bigger than it is now. We all know that Earth has one moon, but there are 2 more asteroids, 3753 Carina and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one, 2002 AA29, follows a horseshoe orbit around our planet. Its specific path brings the asteroid closer to us every 95 years. You'd expect Neptune to be an extremely cold and dark place. After all, it's an ice giant 2.8 billion miles away from the Sun. There's not too much sunlight there, so noon on Neptune is similar to twilight on our planet. But this ice giant appears to be creating its own heat. To be precise, 2.6 times more heat than it gets from the Sun. This probably has to do with all the pressure near the planet's core. It builds and releases hydrogen, which keeps Neptune's center at a crazy temperature of 9,300 degrees Fahrenheit. But its atmosphere is still quite chilly. It ranges from about negative 240 degrees Fahrenheit to negative 330 degrees Fahrenheit. What shape do you think of when someone mentions storms? Probably long ovals of hurricanes and conical tornadoes. But that's something we see on Earth. At Saturn's North Pole, a storm has been raging for at least the past 40 years, and it has a hexagonal shape. Such a weird shape probably has something to do with Saturn's turbulent gas, or maybe even with zonal jets that extend many miles down into a region of extremely high pressure. Have you ever wondered why planets don't twinkle while stars do? The thing is, if you were out there in space, you wouldn't see them twinkling at all. The reason we see stars twinkling is because of Earth's atmosphere. The pin-sized light coming from a star hits the atmosphere. The atmosphere then refracts it, which sends the light skittering off in a zigzag. That's what we perceive as the twinkle. Planets appear much bigger to us than just pinpoints. And yes, their light zigs and zags after hitting the atmosphere too. But those motions cancel each other out, which is why we don't see twinkling, but only a steady glow. In some regions, you can expect big changes in temperature, For example, in Montana, where in a single day, temperatures went from negative 54 degrees Fahrenheit to 45 degrees Fahrenheit. Yeah, sounds like a lot, but it's still nothing compared to Mercury, where temperatures tend to vary over 1,000 degrees Fahrenheit in a single day. They start out at negative 280 degrees Fahrenheit at night and eventually go up to 800 degrees Fahrenheit during the daytime. Picture a wardrobe you'd need to prepare for a single 24-hour visit to Mercury. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. When you think of volcanoes, you probably picture hot molten lava coming out of them. At least, that's how it works on Earth. But in space, volcanoes can spew methane, water, or even ammonia. Up there, a volcano can also spew specific materials that freeze as they erupt. Then they turn into frozen vapor and some sort of volcanic snow. It's a common thing on Jupiter's moons Europa and Io, also on Pluto and Saturn's moon Titan. They're called cryovolcanoes, and Io has extremely active ones. Over there, you'd see hundreds of vents with plumes of frozen vapor that tend to extend about 250 miles. And NASA vehicles have even captured some erupting in real time. Bam! Planets, moons, asteroids, comets, and stars, they can all collide, and galaxies too. Our galaxy, the Milky Way, is 2.5 million light-years away from Andromeda, our closest galactic neighbor. Astronomers believe the Milky Way is on a collision course that will destroy both galaxies in the distant future, or at least galaxies as we know them. The two galaxies are going faster and faster toward each other at a rapid clip, 250,000 miles per hour. It will be chaotic, and many planets and stars won't survive the collision. Eventually, these two massive entities will merge and turn into a completely new, unrecognizable galaxy. But here's a small comfort. Scientists assume this is not scheduled to happen for another 4 billion years. In case you want to fuse two pieces of metal together, you already know the only way to do that is to apply heat so these pieces can reach their melting points. In space, you don't need heat to do such a thing, or basically, any action at all. We call it cold welding, and such a phenomenon happens when you slide the metal pieces over each other. In that case, they wear away their protective oxide layers. On Earth, these layers stop them from fusing, but in space, this type of protection disappears. That's why the electrons from one piece of metal just flow into the other piece. And ta-da! They're one without any effort. Scientists used to believe the Earth was the only planet in our solar system with tectonic activity going on. Tectonically active means plates under the crust are moving. This process releases heat, which then deforms the Earth's surface and leads to its shrinking. But now, we know this happens on other planets too. Mercury is also shrinking, and scientists found it out in 2016 when the Messenger spacecraft orbited the planet and sent back some important data. It revealed that there were cliff-like landforms known as fault scarps on Mercury's surface. Since these landforms are relatively small, they probably didn't form that long ago. That means Mercury is still contracting, even 4.5 billion years after our solar system was formed. Jupiter's Great Red Spot is shrinking as well. It's a huge storm that rages on the planet's surface. It's reddish, a bit oval in shape, and more than 10,000 miles wide. Yep, that's big enough to swallow the Earth. And now, it's been slowly but surely shrinking for a couple of centuries. The Great Red Spot is just one of many high-pressure storms that occur across Jupiter due to all those gases present there, which is something that classifies Jupiter as a gas giant. But just because it's shrinking doesn't mean the Great Red Spot is going to blow itself out anytime soon. It's even growing taller. Way back in the Victorian era, a strange celestial body appears to have popped up in our solar system. Was it an asteroid? Or maybe a comet? It took us until October 2017 to notice it and to start studying it closely. It was named Oumuamua, which is Hawaiian for scout. Not only is its shape extremely unusual, highly elongated and narrow, but it's also speeding so fast that it appears the sun's gravity doesn't affect it so much. So what is this strange, wandering rock? Specialists at first thought it mostly looked like an asteroid, but they took a closer glance and concluded that it was most likely a comet. They believed it's propelled by little jets of gas caused by the warmth of the sun, which could drive it off its natural course. Apart from the way it moves, the looks of Oumuamua are also special compared to those of other comets. These types of celestial bodies reflect about 4% of the light that falls on them. Oumuamua, surprisingly, has double the reflective properties. Sadly, we aren't able to study this bizarre object anymore since it has already left our neighborhood in the solar system. We've heard so many stories about the Bermuda Triangle, from its mysterious events to very detailed scientific explanations as to why they happen at times. Well, you'll be surprised to know there's a space equivalent to the Bermuda Triangle, which some astronauts claim to have witnessed. What they described was similar to an intense flash of light as they passed through a specific location, which they then called the South Atlantic Anomaly. There could be an explanation for this. Firstly, it's important to know the Earth's magnetic field is not perfectly aligned to its rotation axis. There is an area of about 125 miles above the South Atlantic where some type of radiation is as close to the Earth's surface as possible. When passing through this location, computers stopped working, and space staff saw those cosmic bursts of light I mentioned. As far as we know, there are 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But could there be another one, the 9th planet out there that we've yet to discover completely? Some astronomers are certain there is, and they're currently calling it Planet 9. Its location seems to be way beyond Neptune, the 8th planet we've known so far, and the farthest away from the Sun. The problem is, we've been wrong before. In 1801, we stumbled upon Ceres, what we now know as the largest asteroid in the solar system. But we initially believed it to be a planet too. And you must know the story about Pluto. First, we believed it was a planet right after we discovered it in 1930, but then reclassified it as a dwarf planet. The fact that Planet 9 is so far away from us makes it difficult to photograph and study, hence its uncertain status. For specialists to track Planet 9, light has to travel all the way out there from the Sun and almost all the way back again. Astronomers were able to cover somewhere around 30% of the area where this planet is supposed to be. They also estimate it will take about another 4 years to study the rest of it and make a conclusion. A nebula is basically a huge cloud of dust and gas somewhere in space. Some of them come from dying stars after they've exploded. Others are the locations where new stars are beginning to form. That's why some nebulae are even called star nurseries. They can come in many different colors and sizes, but one in particular caught the eyes of astronomers because of its spectacular shape. It's called the Red Rectangle Nebula, and it's located in the constellation of the Unicorn, about 2,300 light-years away from us. We don't know exactly what causes that unusual shape, but one explanation could be that there are 2 stars at its core. These stars could create 2 cones of bright dust, which together make the nebula look like a square. What's even more puzzling about this formation is that it displays something called extended red emission. This means that its dust has a specific reddish glow. It's difficult to tell what causes this, but those 2 potential stars in the middle certainly have something to do with it. Remember when I mentioned Neptune is the most distant planet in the solar system? It's around 30 times farther from the Sun than we are. It would make sense for it to be the coldest out of all the planets, but here comes the surprise, it's not. And scientists have yet to pinpoint why. In 1989, NASA's spaceship Voyager 2 passed by both Uranus and Neptune. It found that Neptune was warmer than its neighbor, even though it was farther away from the Sun. Scientists came up with a bunch of theories trying to explain this staggering discovery. One of them had to do with the gravitational differences between Uranus and Neptune. Neptune's blue hues are more intense than those of Uranus. So, NASA researchers believe there's another unidentified chemical in Neptune's atmosphere. It could explain the unusual temperature. The weather could also have something to do with it. Neptune apparently has the strongest winds and the most massive storms in our solar system. In 1989, for example, Voyager 2 detected a massive blizzard on Neptune, which they named the Great Dark Spot. This storm was bigger than our whole planet. It disappeared in 1994, so there's little we can understand about it these days. These extreme winds can push frozen methane through the planet's atmosphere and mess up the temperature. Uranus is a bit weird itself on a closer look, apart from it basically being a huge ball of gas, of course. Why is that? Well, firstly, because it rotates on its side, making it look like it rolls around the sun like a ball. This curious orientation, about 90 degrees sideways, is probably because of some kind of massive collision that happened in its past. This tilt is also the reason why Uranus has the most extreme seasons in the solar system. 1 year on Uranus is as long as 84 Earth years. For about a quarter of this period, the sun shines straight over the north or south pole of the planet. This could explain the huge difference between its highest and lowest yearly temperatures. Let's also look at the little ones for a bit, shall we? I mean Mercury and Pluto. Mercury is already the smallest planet, or second smallest if we count the dwarf planet Pluto, of course, in our solar system. It's also the second densest after our planet, and it's getting smaller and smaller and denser at the same time. For a long time, we thought that our planet was the only tectonically active one. That was until we discovered that Mercury was still active in this department also. So that's probably the reason why it's shrinking and compacting as time goes by. Pluto's atmosphere is giving scientists a lot of headaches to this day. They revealed that it has about 20 layers in its atmosphere, and they're cooler and more compact than they initially estimated. NASA's New Horizons team also discovered that the dwarf planet releases a huge quantity of nitrogen each hour, but somehow Pluto can constantly restock on its lost nitrogen. Maybe it's thanks to some intense geological activity. Just like most participants at talent shows, we also have a failed star in our solar system. Sorry, Jupiter, we're talking about you. It may not be the most appropriate description in terms of astronomical facts, but some specialists do call Jupiter a failed star. That's because, similarly to a star, Jupiter has a lot of chemicals like hydrogen and helium. At the same time, Jupiter doesn't have nearly enough mass to start a fusion reaction in its core and transform into a star. Stars generate their energy by mixing together hydrogen atoms under extreme heat and pressure, which creates helium. As this process takes place, it releases light and heat, which gives stars their appearance and temperature. How do they manage that? Well, they have a significant amount of gravity for starters. For Jupiter to flare up a fusion process and transform itself into a star, it would need to be more than 70 times heavier. In theory, if we could mix together a lot of Jupiters, we might have ourselves a new star. But sadly for it, in our solar system, Jupiter will have to stick with being a huge lump of gas. Biggest of them all, though. You and your camera have been literally everywhere on Earth, on top of Mount Everest and at the bottom of the Mariana Trench. You've seen the Nile River, Niagara Falls, the Sahara Desert, the Grand Canyon, and a million other beautiful places. On every trip, you brought back breathtaking pictures. Your album is already as thick as an encyclopedia, and it's time to discover a whole new world of tourism. Let's head on a voyage to Mars. You're sitting in a shiny modern rocket, counting down for takeoff. It might seem like a big deal, but with modern technology, it's practically a ride on a bus. In only a couple of hours, you're on the surface. It's time to head to the first destination for any tourist on Mars, Olympus Mons. It's the size of the entire state of Arizona and is 16 miles high. That's 3 times the size of Mount Everest. And it's the highest mountain in our entire solar system. It's actually even more than a mountain. It's a giant volcano. This entire mountain was formed when streams of lava rose to the surface, flowed down the volcano's slopes, and slowly cooled. The freshest soil layers are about 2 million years old. So scientists don't rule out the possibility that this volcano will wake up one day. Hopefully, you're not close by when it erupts. And there are statues of Greek deities everywhere. There's Apollo, and there are Athena and Artemis, and here's Zeus and Neptune. In the myths, these deities lived on Mount Olympus in Greece. These aren't natural, of course. We built these monuments to attract more tourists. There are even plenty of souvenir stalls where you can buy a lightning t-shirt in honor of Zeus. You take your first picture on Mars and move on to the next exciting place. This is a complex of 12 giant volcanoes. Some of them reach almost the height of Olympus. It's like if you piled 60 Empire State Buildings on top of each other. They're so tall because gravity is much weaker on Mars than on Earth. There isn't as much force pushing down on them, so they can grow much bigger than anything you could find on Earth. You feel lighter than you've ever felt before, and you can lift objects 3 times as heavy as you could back home. It's easy to see why the volcanoes are so big when you jump and fly 9 feet into the air. These volcanoes have been erupting for almost 2 billion years. That's almost half the age of our home planet. That's another reason they've gotten so tall. Click! The photo is ready, and you get on the rover to explore the next landmark, Valles Marineris. This is the largest canyon in the world. It's longer than the distance from New York to Miami, and it's 4 times bigger than the Grand Canyon here on Earth. We don't know exactly how it came to be, but the most popular theory suggests that it was all because of the lava, which pushed the crust upward as it moved underground. Over time, these valleys grew into the enormous canyon of Valles Marineris. The next stop is Cydonia. The cool thing about this place is the giant rock with a human face. In 1976, we saw photos from the surface of Mars and could clearly recognize a human head here. People immediately came up with 1,000 theories as to how it could have appeared here. The fun theorizing and speculation came to an end, though, when new photos were taken in 2011. These clearer pictures showed that the eyes, nose, and mouth were just shadows that couldn't be picked out in the original low-quality image. In fact, it's just a hill, a lot less exciting up close. Wear a warm jacket to view the next landmark spot. This is the North Pole. Make sure you keep a tight hold of your camera too. It's pretty windy out here. That ice that you see is carbon dioxide, which looks like that because of the extremely low temperatures. It can get cold here at negative 226 degrees Fahrenheit. This cold place and the North Pole are responsible for the strong winds all over the planet. And there are even geysers at the South Pole. In spring, when it gets warmer, jets of carbon dioxide rush to the surface, taking dust and sand with them. Quick, get it on your camera! Various studies say that there is an underground lake as wide as Delaware Bay, 1 mile beneath a thick layer of ice. Moving on to Gale Crater. This is where the Curiosity rover landed in 2012. Oh, and here's its replica. This little guy has been studying the surface of Mars for years and has found signs of evaporated water. This means that Mars could have fostered life in the past. The rover also found a lot of evidence of organic molecules, as well as methane gas. It could come from microbes and other living things, but we don't know enough yet to say for sure. The existence of life on Mars hasn't been confirmed, but it's exciting to think that there could have been real Martians alive at some point. You take a selfie, like you're holding Curiosity on your arm. Great, the Mars cab is already here for you, and you're heading toward Medusae Fossae. Many people believe that this could be an alien crash site because of the strange appearance of these rocks. Of course, that's not true. Scientists suggest that volcanoes have been erupting here for years. Lava has cooled into rocks, and strong winds have given them strange shapes. This entire volcanic deposit covers an area the size of a fifth of the United States. And here's a place that has made Earth scientists nervous and even scared. Hale Crater and these lines on the slopes. Studies have shown that this place was moistening, meaning that water could flow there. But then it was determined that it was dry sand streams. Scientists fear this place may be home to alien microbes, so you probably shouldn't get too close. Another mysterious place for tourists on Mars is ghost dunes. In the ancient times of this planet, there were dunes dozens of feet high, but then they were flooded by water or lava. Their bases are preserved, but the tops have been erased. The covered areas of these dunes can still harbor microbes. Here, they are protected from wind and solar radiation and may still be preserved. Contact with them can be dangerous for humans, so you take a photo from afar. The next spot is on Mars's satellite, Phobos. Oh, there's a pretty big crowd of people gathered here. And then you see it, Phobos monolith. It's a massive rock as tall as a 30-story building. We learned about this object from pictures taken back on Earth. The monolith casts a great shadow and has spawned many theories. For example, some claim that it was built by an ancient civilization or was left here by aliens. It might even have been a beacon. All these people came here to test the theory for themselves, but it just looks like a rock up close. One more photo, and you have to hurry to the bus that will take you to Jupiter's satellite, Io. It's only safe to be here in special capsule cars that fly over the surface. And when you see volcanoes constantly erupting, you understand why. Jupiter's gravity compresses the insides of Io. They heat up and rise to the surface, erupting in volcanoes on its surface. They eject so much material that Io completely changes its surface every few millennia. Now we turn on the hyperdrives and head out into deep space. Here, in complete darkness, is the Voyager probe. It was launched in 1977 and is still in operation. It's the first human-made object to leave our solar system's borders and is the world's most distant spacecraft. Voyager carries a golden disk with a message for extraterrestrial civilizations. This amazing disk contains pictures of Earth's landscapes, people, animals, and various sounds and music. Unfortunately, it will take many thousands of years to reach the nearest star system, so we're not very likely to hear back from any aliens anytime soon. You take selfies and move on to the next part of the tour. Here, 1,000 light years from Earth, is a black hole, the most mysterious and heaviest object in the universe. It weighs as much as the sun, but it's much smaller. It's so heavy that it attracts absolutely everything, even light. So the black hole isn't actually black. It has no color at all. You can only observe it from a very great distance because it bends time. The closer you are to it, the slower time will go. And if you want to fly just a second closer to it, weeks or even months might pass on Earth in that time. In the old tradition, you toss a coin into the black hole and continue your journey through the distant cosmos. On the way home, you have to stop by an iconic spot on the moon. Here in the Sea of Tranquility, there's an entire park near the landing site of Apollo 11. This is where the first human set foot on the surface of the moon. Neil Armstrong's first boot print is still there on the surface as proof. It was made in 1969, but even now, it looks exactly the same.
Back in May 2015, David Hull took his metal detector and went looking for gold. He picked the perfect spot for it. Mayborough near Melbourne, Australia, was the top location down under during the gold rush in the 19th century. The detector beeped, showing there was something precious hiding in the ground. David found a very heavy reddish rock with a weird, dimpled surface resting in some yellow clay. As it turned out later, the find was indeed priceless, but only for science. David took the rock home, hoping he'd be able to open it and find a gold nugget inside. He tried a rock saw, an angle grinder, and a drill, and put the rock in acid. Nothing worked. Not even a sledgehammer did the job. A couple of years later, He decided to take the rock to Melbourne Museum and finally find out what it really was. It turned out it was a meteorite, and a rare one. The geologist working at the museum was over the moon, as after years of looking at thousands of rocks that people had thought to be meteorites, he finally got his hands on the real thing. The space origin of the rock explained why it was so unusually heavy. It contained dense forms of iron and nickel, and those guys weigh a lot. And it got its dimpled surface because it started melting when it plunged through Earth's atmosphere. Scientists named the meteorite Maribro after the place where it was found and used a diamond saw to study it better. They sliced off a sliver of the space rock and saw some tiny crystallized droplets of metallic minerals throughout it. Those minerals formed during the early years of our solar system. It means the space guest was around 4.6 billion years old. The researchers are still not quite sure where the meteorite came from or how long it's been on Earth, but they've got some guesses. Our solar system used to be a swirling mix of dust and chondrite rocks. Gravity did its thing and formed planets, but there were some leftovers, and most of them ended up in a massive asteroid belt. The Maribro meteorite likely took a detour from the asteroid belt between Mars and Jupiter. It got bumped out of there by asteroids crashing into each other, and one fine day, it decided to crash into Earth. Carbon dating says that this space rock has been chilling on Earth for somewhere between 100 and 1,000 years. There were meteorite sightings in the 19th century that could match up with when it made its grand entrance. The scientists say the Maribro meteorite is even rarer than gold. It's only the 17th meteorite ever found in the Australian state of Victoria and the second largest. In the 80s, David Mazurek from Michigan decided to buy a farm not far from Mount Pleasant. The new property came with a weird bonus, a large rock that kept the barn door open. The farmer explained the rock was a meteorite. It had literally fallen from the sky in the 30s. The farmer and his father found the crater the meteorite had left and dug out their guest from space, which was still warm. They couldn't think of a better use for it than to serve as a doorstop. I mean, what else can you do with a meteorite? The new owner got to keep the unconventional doorstop and must have grown fond of it. When he was moving to a new home, he took the rock with him and used it for the same purpose for another 30 years. Sometimes David would let his kids take it to school. It must have gotten some easy A's in physics and astronomy. Then he heard that other Michigan residents find and sell pieces of meteorites for some serious cash. Since his piece was an impressive 22 pounds, he decided to take it to Central Michigan University to find out its value. A local geology professor was getting tired of similar requests because, for around 18 years, she had to explain to people all the rocks they had brought her weren't meteorites at all. But this time, she felt it was the real thing. She tested the rock and determined it was a meteorite made from iron and nickel. It turned out to be the 6th largest recorded find of this kind in Michigan, and the most valuable specimen she's ever worked with. They sent a slice for another round of verification to the Smithsonian Institute in Washington, D.C., and soon it was all official. It turned out that the meteorite was a piece of an early solar system. The Smithsonian and a museum in Maine offered some good money for the space rock. Mazurek decided to sell his meteorite to Michigan State University's Abrams Planetarium for $75,000. He generously shared 10% of the money with Central Michigan University's Earth and Atmospheric Sciences Department, where they confirmed the rock's true identity. I hope the money he was left with was enough to buy a new doorstop. While some use meteorites as furniture, scientists have found a way to utilize them to extract oxygen from water on Mars. Traveling to the red planet is impossible without oxygen. We need it both to breathe and fuel rockets for a return trip to Earth. The new robot, called AI Chemist, hunts down a compound that can kickstart a chemical reaction on Mars to produce oxygen. The compound is crafted from elements found in Martian meteorites. this planet only has traces of oxygen in its atmosphere. But scientists have found there's some liquid water underneath the southern ice cap of Mars and more water under its surface. So, they needed to figure out how to break down this water into its hydrogen and oxygen molecules using materials available on the red planet. The AI chemist analyzed 5 meteorites that either came from Mars or were similar to that of its surface. It used a laser to locate large amounts of iron, nickel, calcium, magnesium, aluminum, and manganese in the samples. These elements will be enough to produce more than 3.7 million possible molecules to break down water and generate oxygen on the red planet. Finding the right algorithm for this process would take us humans around 2,000 years, and the robot managed to do it in a matter of weeks. Using the meteorite compound as a catalyst, the robot managed to do its job in -35 degrees Fahrenheit on Earth, and it did so without any human help at all. Now the question is, if it will be able to do the same on Mars, where the atmospheric composition, air density, humidity, gravity, and other conditions are trickier than on Earth. Other scientists previously managed to produce small amounts of oxygen fit for breathing up there. An instrument the size of a lunchbox on NASA's Perseverance rover compressed and heated carbon dioxide from Mars's atmosphere. It generated oxygen at around the same speed as a small tree. I think Matt Damon's character from The Martian would have loved all these advances in space science. Thousands of meteorites crash into our planet every year. 95% of them are thought to come from just 2 sources. 75% from the crust of a big asteroid, and 20% from the mantle of an even larger celestial body that bit the dust ages ago. But in May 2020, researchers stumbled upon some meteorite pieces in the Sahara Desert that were like nothing they'd seen before. They were labeled as ungrouped achondrites, a type of rock that formed from melted minor planets way back in the solar system's early days. This makes the find slightly older than Earth itself. But unlike others of its kind, this meteorite was made out of andesite, which made it even more unique. It could serve as proof that the early protoplanets in the solar system and a ton of other debris either got wrecked or joined forces in building the rocky planets we know today.
The year 2022 was rich in amazing discoveries. Let's have a look at the most impressive of them. The newest of NASA's rovers, Perseverance, keeps exploring the surface of the red planet. Right now, it's hunting for signs of ancient life in the Jezero crater. That's a 28-mile-wide impact crater. It was likely once filled with water. While trekking across the crater's floor, the rover spotted several surprising things. One of them was a weird purple coating on a few rocks. It was strangely similar to rock varnish formed by microbes on our planet. Scientists haven't figured out what it is yet. The rover has also been very successful in adding new samples to its rock collection. It's got 14 pieces of rock. They'll be stored on the surface of Mars for future missions to collect. NASA and the European Space Agency have been developing different plans for getting hold of these samples. Most of them involve a few spacecraft and even several helicopters. How about something more down to Earth? In June, a giant freshwater stingray was discovered in the Mekong River in Cambodia. A fisherman called Mao Tong accidentally snagged it while fishing. He called researchers, claiming the stingray was way larger than anything he had ever seen. The scientists arrived and found out that the creature measured 13 feet from snout to tail. It also weighed a staggering 660 pounds. This made it the largest freshwater fish that had ever been recorded. It was even certified by the Guinness World Records. Another animal-related discovery: scientists have found evidence that spiders might see dreams. One scientist studying these creatures noticed that when snoozing, little arachnids jerked while dangling from a thread with their legs curled. It resembled the way cats and dogs twitch while dreaming. The researchers set up a whole lab to observe spiders. The resulting study revealed that jumping spiders indeed experienced a sleep-like state that included the rapid eye movement stage. And with 8 eyes, that's a lot of twitching. Researchers identified the remains of a 17th century Spanish galleon. It was found near Oregon's north coast. Experts think that those are the remains of Santo Cristo de Burgos. In 1693, this vessel was traveling from the Philippines to Mexico, but at one point it veered off its course and disappeared. The lost galleon was known as the beeswax wreck. It got such a name because it was carrying blocks of beeswax. People had known about the ship for a long time, since parts of its cargo were often washed up on shore. But until recently, no one knew the name of the ship. But then researchers analyzed timbers discovered in a cave near Astoria. The analysis revealed that those were made from hardwood used to build ships in Asia in the 17th century, which meant the mysterious vessel was the perfect match for Santo Cristo de Burgos. Now, early in 2022, scientists noticed something alarming in West Antarctica. They already knew that the wedge of the continent sitting south of Argentina might raise the sea level by 10 feet. The thing is, our world is changing, and some of that ice is going to melt one day. But that's not the worst news. Experts spotted ominous hints that a massive collapse could occur really soon. A large ice shelf cracked suddenly. This ice shelf stops the ice sheet from slipping into the ocean and melting away. If this rupture widens, it might kick off a catastrophic chain reaction. Elsewhere, it was January when a submarine volcano, known as Hunga Tonga Hunga Hahapai in the Kingdom of Tonga, erupted. The event was unlike any other witnessed in recent decades. The blast was so powerful that it sent a pressure wave all over the globe, and it traveled around the world not once, but several times. It also produced giant tsunami waves. Scientists claim that everything about the eruption was extremely weird. For example, how insanely powerful it was, or the cascade of effects that followed. The eruption excavated more than 2 cubic miles of rock from the seafloor, becoming the largest volcanic blast in the past 100 years. It also unleashed tons of volcanic rubble and hot ash that moved along the seafloor for a whopping 50 miles. Also in January, scientists discovered a site in southeastern Australia with rocks that contained a breathtaking record of life. The fossils found at McGrath's Flat are estimated to be from 11 to 16 million years old. Those are soft-bodied small creatures, including spiders, and they're preserved in such extraordinary detail that you can even see the spider's leg hairs. The researchers also managed to spot tiny pores in fossilized leaves. Those pores used to take in carbon dioxide. Scientists discovered several new snail species while searching for animals in Southeast Asia, and they believe that 2 of these species are the smallest of all seen before. One of them lies in Vietnamese caves and is a mere 0.02 inches in length, which means if you decided to put them on a U.S. quarter, many hundreds would fit there. Now, I bet you heard of NASA's James Webb Telescope. It's a giant infrared instrument, and it's floating in space millions of miles away from our planet. It spent the first part of 2022 preparing to take its first images, and in July, the world finally saw those pictures. The images of the cosmos taken by the telescope are incredibly detailed. In fact, one picture was even called the deepest view of the universe ever. Among other pictures, there is a now iconic image of the Carina Nebula. Another one is a stunning view of Neptune's rings. At the moment, the telescope has a long list of observations it has to do. It's supposed to explore everything, from distant exoplanets to the oldest galaxies out there. Now, you probably know that 65 million years ago, give or take, life on planet Earth changed forever after a 6.5-mile-wide asteroid crashed into our planet. This catastrophic event caused a mass extinction, which, in turn, led to 3/4 of all species, including dinos, disappearing from the face of the Earth. In February, scientists got exciting new information about the disaster. They studied some fish fossils and concluded that the asteroid had hit Earth during spring in the northern hemisphere. Another discovery was made in March. It turns out that right after the impact, rocks started to rain down more than 1,000 miles away from the impact site. And in August, scientists found something that could be a fragment of the asteroid off the coast of West Africa. It probably broke off and slammed into Earth separately, leaving an undersea crater. Now, brace yourself. Earlier this year, scientists grew brain cells in a lab and taught them to play video games. Yeah, I know, that's wild. Researchers from Australia claim they created the so-called mini-brains that could sense and respond to their environment. Each brain consisted of 800,000 cells. When viewing video games, they produced electrical activity. And even though they often missed the ball in a particular game, the connection rate was higher than a totally random chance. A research team funded by the National Geographic Society discovered a curious fossil in August 2022. It belongs to the oldest dinosaur found in Africa, this guy, whose name I can't pronounce. This ancient creature lived about 230 million years ago. It was one of the earliest ancestors of sauropods that we know about. This group includes such long-necked giants as the Brontosaurus. But unlike them, the dino we're talking about wasn't a giant. Scientists think it was probably a mere 2 feet tall at the hip. And some more great news. We now know for sure how to nudge asteroids off track. NASA made a spaceship known as DART crash into an asteroid. The main goal of this experiment was to check whether such a collision could change the course of the asteroid, knocking it off its orbit. This method could help us avoid a potentially catastrophic asteroid strike. The spacecraft, which cost $325 million and was the size of a vending machine, slammed into asteroid Dimorphos at a speed of 14,000 miles per hour. The spaceship burst into pieces right away. But the mission still seemed to be a success since Dimorphos was indeed affected by the collision to a measurable degree. So, maybe we won't need Bruce Willis and his gang after all. Do you know what the third brightest object in the night sky is? If you said the International Space Station, you're absolutely right. And the coolest thing? You can sign up for a special service and you'll get a text every time the ISS is traveling over your location. And if it happens at night, you can see it with the unaided eye. But be quick, because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. If you moved at such a speed, you'd be able to make a round trip to the moon within a day. At the same time, the ISS isn't the fastest human-built object. This title belongs to the Parker Solar Probe that travels around Venus and the Sun at a speed of 430,000 miles per hour. On the bright side, astronauts on the ISS see a sunrise and sunset 16 times every 24 hours. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view bay window. And now, let's imagine what your life would be like if you were an astronaut on the International Space Station. Now, for one thing, you'd be able to do some cool things there, like throwing boomerangs. Once, an astronaut threw a boomerang inside the International Space Station, and it returned to him. So, just remember, as long as there's some air, even weightlessness won't stop you from having a bit of fun. On the ISS, you would never have to deal with disgusting smells. There's a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station, costs more than $10,000. That's why it costs less to throw your clothes away when they get dirty than to waste water on washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you'd get oxygen deprived. But what would you do on the ISS? Most likely, it would be space-related research. Astronauts on the station not only explore the possibility of future space travel, but also conduct all kinds of studies and explore the effect of microgravity on the human body. Oh, and speaking of microgravity, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit the Earth, and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means very small gravity. Earth's gravity on the International Space Station is only around 10 to 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, they're very different things. Anyway, on your way to the International Space Station, you'd be wearing a bright orange spacesuit. Its color is called International Orange, and it has the same shade as the paint that coats Tokyo Tower in Japan or the Golden Gate Bridge in San Francisco. But once you reach the vast expanse of space, you'd swap orange for Snow White. See, the thing is, the orange suit is equipped with the stuff that can help astronauts survive if something goes wrong during the launch or landing of the spaceship. For example, a regular pumpkin suit has flares, medications, survival gear, a radio, and a parachute. As for the white bulky spacesuits, those are EVA, which stand for Extravehicular Activities suits. Their purpose is totally different from that of the orange suits. Astronauts put on EVA suits when going on a spacewalk. Such an outfit can protect them from the unfriendly conditions of outer space, with its extreme temperatures and the near vacuum. Besides, the white suit can prevent small debris from hurting space travelers. Oh, by the way, if you needed to scratch your nose while wearing your EVA suit, you would use a patch of Velcro inside the helmet. The lack of gravity also makes sneezing inside a spacesuit a serious problem. If you absolutely had to sneeze while on a spacewalk, you'd have to bend your head downward and sneeze into your chest. Otherwise, your visor would have to be equipped with tiny windshield wipers. Now in space, you'd often see random flashes of light, and those wouldn't be hallucinations. Cosmic rays hitting your optic nerve would create such an effect. You don't see similar flashes here on Earth because the magnetosphere doesn't let cosmic rays reach you. Before going to space, you'd have some underwater training. It's supposed to simulate zero gravity, but in fact, it has nothing in common with being in outer space. So the main purpose of this training is to see how future astronauts can deal with extreme environments. Oh, and later, during space adaptation, you might feel, well, let's say, weird. Around 50 to 75% of astronauts have highly unpleasant symptoms, such as vertigo, headaches, nausea, and overall tiredness. Luckily, everything usually gets back to normal within 72 hours. Before you were chosen to fly to space, you'd have to get through incredibly tough competition. According to NASA, they accept only 8 applicants out of 6,000. On top of that, the selection process takes around 18 months. Now, if you felt homesick on a mission and started crying, your tears wouldn't flow down your face. Instead, they'd gather into thick blobs of liquid around your eyes because the water surface tension would hold your tears together. You'd have to remember to attach yourself to something before falling asleep. Otherwise, you can easily float away from the spot where you went to bed and bump into a hard surface. That's why astronauts usually rest in sleeping bags in a small crew cabin. Another issue you'd have to deal with would be taking a shower in microgravity conditions, and it's not an easy feat. Astronauts use a shower in an enclosed cylinder which keeps water from floating away. They use a no-rinse shampoo, spray themselves with water to rinse off the soap, and finally use a vacuum hose that pulls inside all the water left on their body. You'd have to get used to a dramatic change in your diet. You'd have 3 meals a day, nothing outstanding here. But instead of sitting down to enjoy your lunch, you'd float around. Your meal would consist of some dehydrated and canned food items, and it might take a lot of time to finish it, since you'd have to be very careful not to let your food get away in the process. Now, imagine needing a haircut. After all, you'd spend no less than half a year on the ISS. To change your image, you'd have to use special clippers with a vacuum attached to them. In the near future, people have made the greatest space discovery in history. The entire population of Earth looks up to the sky to see the greatest astronomical show ever. Is this real? What does it mean? Scientists have been studying galaxies, planets, and black holes millions of light years away. But all this time, something fantastic has been hiding in plain sight right above our eyes, on the moon. Starting a few years ago, humans began going to the moon again and finally set up a permanent base there. While excavating the lunar landscape, one lucky drill smashed into something like a metal plate. It turns out that metal contains polycarbonate, aluminum, gold, and silver. That's very similar to something humans already have on Earth. It's basically what CDs are made out of. People start going excavation crazy. Who knows what else is down there? The moon turns out to be our greatest resource. After a few months, lunar construction equipment has excavated several hundred feet of the shiny surface. At first, it was kept quiet, but a year later, that becomes impossible. Excavation crews dig out a huge rectangular shiny piece, the size of 10 football fields. And that plate is not alone. There are literally millions of them. After a little more research, scientists discover that the entire surface is covered with this strange material. People gaze up every night at the unusual moon in the starry sky. It glows a little brighter than before. You only need the most ordinary telescope to see that things are about to get weird. The excavation work isn't complete, but scientists have concluded that the moon is a huge disco ball. Who created it? For what? And what does this mean for us humans? No one has any answers. Soon, humans managed to dig up more than half of the moon. In some places, the plates are too deep to get to. They're stuck under mountains. In other places, the plates of the disco ball lie directly under the surface. Somehow, even with this crazy discovery, the properties of the moon haven't changed in any way, except that it's become brighter. Attempts to dig deeper, to pierce through the plates, are hopeless. The layer of polycarbonate and metal alloys is too thick and seems to go deep into the core of the moon. Some scientists suggest that if the moon's surface resembles a CD, it might just mean that there's some information recorded on it. That would change the course of history. They decide to build a laser reader to see if the moon really is a whopping big CD. Meanwhile, the drilling continues. On the dark side of the moon, which isn't always dark by the way, people find a small crater. Surprisingly, there's no shiny material inside. This perfectly round hole looks like a dried-up lake. At first, everyone assumes that there was a plate there. It just must have flown off somehow. But then, why was that crater so perfectly round? After a little more investigation, diggers find something that looks like plastic. What's that all about? Then, unexpectedly, the digging stops. The huge rig smashes against a thick alloy of unique durable plastic. There's a perfectly round plastic disc hiding inside the crater, the only one on the entire moon. It becomes clear that this huge disco ball was created by something billions of years ago. It's been covered with cosmic dust ever since. IT specialists scan the entire lunar surface with the help of satellites. They find something. It looks like there's a complex electronic system hidden under the disk. If you look at the moon as a whole, the crater starts to look an awful lot like, well, a button. Time to press play on the moon. To understand what's going on there, scientists try to get through the plastic layer. While they're doing that, there's an accident. An automatic drill explodes under insane pressure. The blast is so strong that it activates the button. All of humanity freezes in fear. There's silence, real silence. Then, it happens. The moon starts to rotate ever so slowly on its axis. Then, hour after hour, it rotates faster and faster. There's a mad rush to get everyone off the moon. Soon, it'll be spinning too fast to take off from safely. A lot of people fly halfway across the planet, where it's night, to see what's up with the moon. Every TV channel, website, blog, vlog, live stream, everyone's broadcasting the same images, those of the great disco ball in the sky. The moon begins to spin so fast that all the loose rock and sand on its surface gets scattered in different directions. Some lunar fragments fall on Earth and create an incredible meteor shower. The moon is spinning faster and faster. Now it looks like a real disco ball. The night sky is lit up with bright rays of white. It's incredible. People are ecstatic, amazed, delighted. But a moment later, all of humanity descends into a deep state of fear. Astronomers report that the moon is approaching Earth. When it gets too close, Earth's gravity will destroy it, and the giant crushed-up disco ball will smash into our planet. Every hour, the moon gets bigger in the night sky. Floods are starting to break out all over the world. People dust off their underground bunkers and get inside. There's no time to blast the moon with a rocket or anything like that. This could be it. The moon creeps closer and closer to the Earth's atmosphere. Then it stops, and nothing happens. Incredible! The disco ball isn't affected by our planet's gravity. Some sort of ancient technology inside the moon just saved us from disaster. Then, a deafening sound booms out from the night sky. It's coming from the disco ball. The sound wave obliterates all the clouds in the sky. It sounds like a roar, a deafening bass that makes the ground shake. It's intimidating, scary, but then a rhythm starts to come out from the wall of sound. Impossible! There's music coming right out of the moon. Then some plates start to change color. They turn purple, pink, blue, green. It looks wild. The different color rays dance around on the Earth's surface. It gives everyone an insane energy boost. Everyone wants to be outside with friends, neighbors, anyone. One moment you're standing under a green glow, and a second later, everything around you gets lit up in pink. The incredible light show creates an unbelievable desire to dance. DJs around the world team up to record a whole new sound that mixes with the moon's music. They call it MLB, the Moon Light Beat. People all over the world go out into the streets and kick off the biggest party ever. Scientists now think that billions of years ago, our planet was inhabited by huge intelligent beings the size of Mount Everest. They wanted a party and set about creating a huge disco ball. Then these creatures moved on to another planet. Earth was getting kind of cramped, and the disco ball was simply forgotten. Over millions of years, dust and rock obscured it from view. For several months, the moon continues to spin, and DJs keep pumping out music. People start to get a bit tired of the whole thing. They want a bit of silence and a calm, starry sky, not a glittering moon disco ball. Humanity starts experiencing mass insomnia and dizziness. All flights are grounded because the bright-colored flashes make it impossible for pilots to see properly. Unfortunately, no one knows how to turn this thing off, and it's impossible to study because the moon's moving around too fast. The problem is solved by itself. The ball stops and returns to its orbit. It's possible that it just ran out of battery. People aren't exactly in a rush to reactivate it, but they leave detailed instructions for their descendants in case they want to throw a